Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to install software Step7 MicroWin V4.0 SP9 for connect to PLC S7-200 by using Windows 10 Professional 64-bit version 2018 on VMware Player. Okay. In the previous video, I already showed a little bit about how to install this software on Windows 10 also, but install on the window, the real window, not inside the virtual machine. So today I will use VMware 16 player for install this software. Okay. So let's go to our software. I will explain step by step about how to install. Okay, so let's go. Okay, so first we need to have the software. The first one is VMware Player. Right now I will use version 16.1. The second we will use the image Windows around 5 GB. And the third, I will use the Step7 MicroWin version 4, and then I will update to version 4 with page 9. Okay. So first we need to have the install the software VMware Player. Yes. To install the VMware Player software, we can download from the internet or we can use the free version. Yes. So first let's install by right click and then run as administrator. Yes. So please follow my step, otherwise we cannot install the Step7 MicroWin version 4 with page 9 on VMware Player. Okay. So click next, accept, and then click next, and then click checkbox to all. Yes. And then click next. And if we would like to create this software on desktop, we can tick here and also show it on the program, start program also. Okay, and then click next and then click install. Yes. So wait a moment for this installation. It take time around 2 or 3 minutes about installing this VMware Player. Okay. In this step, I will use the free version. Yes. Okay, so wait a moment for installation. Okay, so right now we already installed the VMware Player workstation on the Windows. Yes, and then click finish, and we need to restart or we can restart later. So for me, I use the restart later. Yes. Okay, so here is the VMware Player that we already installed. So double click on it. Okay, and then we need to create the new virtual machine. Yes, by click here, create a new virtual machine. Yes, and then we can browse to find the image file that I keep in the drive F. Yes, here, this file. So browse and then go to F yes, drive F, and then go to the folder, yes, this folder, and then choose here. Actually this one, it should be ISO file and also bootable file for this image, yes. So double click here. Okay, so right now let's see here, it detects one Windows 10, yes, and click next. Okay, and here we can choose another version that we would like to install. So for me, I like Windows 10 Pro in Windows Professional, yeah, and then let's click here, and the full name is administrator, yes. So click next, and then click yes. Okay, so here it is the VMware image file. Example, I will choose PLC S7-200, yes, and then go to browse to keep the file that we would like to keep. Example, I keep on drive F, so make a new folder. Example, step 7. Okay, and then click OK, yes. So here we will keep the file, yes. So I will keep file here. Let's see, step 7, and then click next. And here is the capacity of file that we would like to use. Example, I will use 500 GB. And if we would like to store this as single file, we can click here, and here is a multi-file. So actually I like to use the single file, so I select here and then click next, and customize hardware. So in this step we can choose the RAM or CPU core that we would like to use. For my computer is RAM 32 GB, so I will use around 4 GB for this Windows, yes. Okay, so we can click close. So right now I use the 4 GB for this image, and CPU I use 2 cores, yes. Okay, and then click next. So it will install this window with 4 GB of RAM and 500 GB for hard disk, and use the 2 CPU of course. Okay, so let's click finish. So it will create the file automatically and install the window automatically. It takes time around 30 minutes for this step. So we can wait until the window is set up, yes. So in this step, everyone must keep the battery, yeah, must charge the battery of computer to full, otherwise it will shut down automatically, yes, because we run 2 windows on one hard disk, so it will slow a little bit. And for this step, I recommend all of you to use RAM only 8 GB or 4 GB. If we have 16 or 32 GB, yes, it means that if our window is 16 GB or 32 GB, so we can use 8 GB or 4 GB to run this window. Okay, so right now the window is starting setting up. Yes, so wait a moment. Okay, it starting copy window files to the hard disk. Yes, so waiting for this setup. It's up to our computer. If we use the RAM is big and CPU is big, it will faster than the computer that have only RAM 4 GB or 8 GB. Okay, so it will copy step by step. Okay, right now it 94%, so it will restart a little bit after it installation. Okay, so wait a moment more for the installation. Yes, 94%. Actually we use around 30 minutes for this installation of window, or 20 minutes for the computer that have RAM or CPU is big. Okay, so 100%, and right now it installing the features and installing update. Yes, installing update step. So it's very easy for install this software, because for this software it not support for Windows 7 uh, 64 bits, but it support Windows 7 or Windows XP 32 bits. Okay, and then right now it will support the Windows 10 8 64 bits, but version 2018 only. Okay, so it will restart the window a little bit. Yes, so wait a moment. Okay, it will start. Okay, restart the window. Yeah, restart the VMware. Okay, and it will continue to installation after it restart. Yes, so don't touch anything. Wait it installed to be finished. Then we will set up the software Step7 MicroWin. Okay, so right now it's installing. Okay, starting service. Get with this for 80%, 90%, 100%, and it will ready. It continue to restart. Yes, one more time for Windows. So it restarting right now. It will install a little bit more after it restart for second times. Yes, so waiting a bit for this installation Windows. Okay, it installing. Yes, okay, so right now it nearly finished. So the username is administrator that we already set when we create the VMware file. Yes. So take several minutes more, and do not turn off the PC, otherwise it will error. Yes. So should be waiting it for finish the installation step by step. Actually, I have tested another Windows 10 2020 or 2019 version, but it not support. I saw it support only this Windows version 2018. Okay, so if everyone would like to use it, I will drop the link under my video to download both VMware software and Windows MPI software, and Step7 MicroWin V4.0 SP9 software. Okay, so everyone can download and install to PC to use for create the program or communication, upload and download for PLC S7-200 for all version. Okay. Okay, so right now it full screen after it install the VMware tool by itself. Yes. So let's check the Windows version. Okay, let's see here Windows version 2018. Yes, and it Windows 10. Okay, 64 bits operation. Yes. So the next step, we need to copy the software Step7 MicroWin version 4 and version 4 V9 to this Windows. So let's copy. Okay, right click and then copy, and right click and then paste. It takes time around 2 minutes to copy the software from the outside window to the VMware player windows. Okay, so wait a moment for copy the file. Okay. Okay, right now we will got two files. The first one is Step7 MicroWin version 4, and another file is Step7 MicroWin version 4 V9. Okay. So before go to set up this software, let's go to our step. First, go to control panel. Okay, go to control panel, go to programs, go to program and features, and then go to the turn Windows feature on or off. Okay, and the first one we need to create or enable the .NET Frame 3.5. Yes. Okay, after that we will enable the Microsoft message SMQ servers. Yes, it's very important. If we don't enable these two options, we cannot install the Step7 MicroWin. Okay, and then click OK. Okay, it will install. Yes. So in this step, we need to connect the internet. Yes. Example, I will ping www.goodgall.com, so we can ping. Yes, so it means that we need to connect the internet. Okay, otherwise we cannot download the required file of .NET Frame 3.5 to this Windows. Okay, so wait a moment for downloading and installation by itself. Okay, so we just connect the internet connection, then we can install the .NET Frame version 3.5. Okay, so wait a moment for install this software. Take time around 2 or 3 minutes more for the installation. Yes, because it require files. If we don't enable this file, we cannot install the Windows require file. Okay, now it's downloading. Yes, in this step it's up to the internet speed connection. If the internet speed is high, so it install and downloading very fast also. Okay, it nearly finished. Wait a little bit more. Right now it apply change for this option. Yes, around 1 minute more it will finish this installation. So it's very easy for install the software inside the VMware player, because if we would like to install another software, we don't need to install our Windows. I mean that install the outside window, because if we install a lot of softwares, it will slow, right? So we can separate one VMware player, install one software or two softwares, so it will fast. Okay, in this step I will install only Step7 MicroWin. Yes, on this Windows only. So right now it complete the request change, so let's click close. Yeah, okay, and then let's go to next step. So in the next step we need to install the Step7 MicroWin version 4, this file. Yes, okay, so right click and then run as administrator. Okay, and then click OK, click next, click yes to install, and then it will use the folder, default folder. Yes, no need to touch anything. Then click next, it will install the software for Step7 MicroWin version 4 only. Okay, but version 4 is not support for the new version of the PLC S7-200. So we need to set up or upgrade to the page 8 or the page 9. Okay, and this step I will update by using the page 9. So click yes to set up the communication devices. Okay, so wait a moment for this step. It will take time around 5 minutes more for the installation. Yes. Okay, 90%. Yes. Okay, it will install the driver for communication between our PC and PLC. Okay, actually for communication between PLC S7-200, I usually use the PPI cable, but we can also use the Profibus cable or another cable that we can use. So waiting a little bit more for this installation. Yes. Okay. %90. It start installing the driver. Yes. 3%. Okay, go fast. 24%. 84, 100%. Okay, 95%. Yes. Okay, it got error a little bit, but don't worry. Just click OK. Okay, let's see here. Right now we already installed the PC PPI cable interface. Then click OK. Yes. Take time a little bit more for the installation. Okay, installing. So we should follow this step, otherwise it will not work. Yes. So I will restart the computer a little bit. Yes. So click finish to restart the computer. It restart only VMware, right? Because our Windows still run. Let's see. Okay. Right now the window still restarting. So wait a moment more. Yes. Okay, booting, and then log into Windows. Okay, it was done for reboot the window, but it just version 4. So if we open this one to use connect with the PLC, it might be not support the new version of PLC. Okay, so we need to upgrade to version 4 with page 9. So to do that, let's go to control panel. Yes, and then remove this version from the Windows. Yes, okay, remove. Okay, install, restart, and then remove. Yes, otherwise it cannot upgrade. Okay, complete the remove. Okay, so let's see here, it was removed from the Windows. And then let's go to software, Step7 MicroWin version 4 GB page 9. Okay, so waiting a moment. Okay, so that's all. And then go to this folder and then open the folder, and then here is the setup application. Then right click and then use run as administrator to install, and then click next. Okay, and then click next again. Let's see, here is version 4 with page 9. Yes, and then click yes, and don't touch anything for this default folder. Just click next. It will automatically install this software. Yes, so it will upgrade from version 4 to version 4 with page 9. Okay, so it is the latest version of Step7 MicroWin. It CV page 9. Okay, so it will support to all PLC S7-200. I mean that it will support to all Step7 for PLC S7-200. Okay, and after the installation, I will test for everyone about how to upload and download the program to PLC by using Windows 10. Okay, but please remember, everyone must follow this step, otherwise we cannot install this software to our Windows or VMware player. Okay, so wait a moment for installation. It here not yet finished, so wait a moment. It installing. Yes, right now. It will occur the progress after it install. Yes, so it minimize by itself. Here there are two steps. So we can install other software inside the VMware player to use the same as our Windows. Yes, let's see here. Progressing installation the device drivers. It take time a little bit, around 3 minutes more about this installation. So wait a moment. So right now the Windows is updated. Then if we use Windows 7 or Windows XP, all the can use, but it not some driver or some software. It's not support the old operating system. Yes. Okay, it occur the error a little bit, but don't worry. Just click OK. It will continue to installing. Yes. Okay, it continue by itself. Okay, it will occur on the desktop right now here. The shortcut of step 7 MicroWin. Okay, that's all, and then click OK, and then we will restart the computer a little bit more. Yes, so click finish to restart the computer. Okay, the computer is restarting by VMware player image. Okay. It will log in to the Windows automatically because I'm not yet create the password. Okay, so it successfully for installation. Let me open. Yes, we page 9. Let's see. Okay, let me open. Wait a moment for opening the Step 7 MicroWin version 9. Okay, and then check the communication. Yes, let's see. Go to set PC interface. Then choose the PC PPI cable and choose property. And let's see, here is the USB. Yes, so if occur like this, it means that we can communication by using the PPI cable. Okay, let's click OK and then click OK. Yes. So I will test with the real PLC for show to everyone about how to upload and download for this software. Okay. So here let's check the version. Okay, version 4, CV page 9. Yes, so successful. So let's go to test with the real PLC. Let's go. Okay, right now we will connect with the PLC by using the PPI cable to communication for test this software. Okay, so let me insert the PPI cable that connected from the PLC S7-200 CPU 226 CN, yes, to the PC. So let's go. Okay, if I connect the first time, it will ask what is the host that we we would like to connect. So I will choose the virtual machine because right now we use the VMware player. So select here and then click OK. Yes. To test the communication between our PC to the PLC, let's go to open the Simatic MicroWin version 4 SP9. Yes. And then choose the set PC interface. Yes. And go here PC/PPI cable PPI 1 and then choose property and make sure we select to the USB. Yes, and then click OK and then click OK again and click the communication tab and then we can click refresh here to check our communication between our PC to the PLC. Okay, by double click here. Okay, so wait a moment for communication. Yes, double click one more time. Yes. So right now it detects one CPU here, CPU 226 real version 2.01. Yes, and then click OK. Yes, and we can download and upload the program that we want. Example, I would like to upload the program. Let's see the upload button. Yes, and if I want to save, I click yes to save the program. Example, save to desktop, and this is a backup. And then click save. And we can click upload button to upload the program from PLC to keep on the PC. Okay, so we can click upload. Yes, so wait a moment for uploading the program. Okay, so here is the existing program that we already learned in the previous video. So we can use Windows 10 64 bits to download and upload. Okay, so let's save the project. And if everyone would like to download for test, okay, we can write. Example, I want to on off the Q 0.0 via timer. Example, SM 0.5. It is one reset on and off. Okay, so we can compile. Okay, error 0, and we can download. Click download button, and we must click the communication again before download. Okay, and then click OK, and we can download. Yes, stop the CPU. And start the CPU again. So we can online. Yes. So on off every 1 second. Yes. So let me show the condition of PLC. Okay, let's see on and off, on and off. Yes. Every 1 second. Yes. So this is a instruction about how to install the software Simatic version 4 Step 7 MicroWin V4.0 on Windows 10 64 bits version 2018. Okay, so it supports also for this software. Okay, So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to wiring the PLC S7-200 CPU 224 for control the motor 3-phase forward and reverse. And in this section, I will use PLC S7-200 simulation with PC Sim for control the motor. Before we create the program for simulation, I would like to explain a little bit about how to wiring the input and output of PLC S7-200. Okay, in here is the input part that we need to know about how to wiring. When we provide 220 volt AC to the PLC, we will got 24 voltage DC from here. Elbow is plus, M is minus. And actually we can jumping the command for 1M, 2M, and M. Yes, it is the minus. And we can take the plus for positive to the push button or to the limit switch or sensor that we want. Okay, and then here is the input I 0.0, I 0.1, I 0.2, and then here is I 1.0 until I 1.5. Okay. For output part, we can also jumping the 220. It is the phase to here 1L. It means that 220 L. And for natural, we can connect to the overload or magnetic coil of contactor. Okay. And for Q 0.0, I will connect to the coil of magnetic contactor K1 for start forward. And Q 0.1, I will connect to the K2 of magnetic contactor for start reverse. Okay. And for overload relay, we can connect like this. If motor overload, it will cut the natural, so this contactor cannot be on. Okay. And when the motor overload, it will send the signal to the PLC, right? I3, yes. I will use one more for I3. Yes. Send signal to the I3 for overload signal. Okay. And for all button start, forward, reverse, and stop, I will use nominal open for connect. Okay. So first I will show the simulation, and then I will explain and practice step by step about how to create the simulation for S7-200. Okay, so let's go. Here is the sample that I already created for show to everyone, and then I will delete this one and then create again. Okay, there are two software that we will use. First is S7-200 simulation, and second is PC Simu. Okay, so right now I can online from the PC Sim software, and then I can start forward. Yes, for start forward, you see here is start forward, and then the motor will rotate with clock with, and then I can stop. Yeah, and if I would like to start the reverse, I can also start the reverse. Let's see, Q0.1 is turned on. Yes, here, and then the motor will run for anti-clockwise. Okay, so it is the sample program. So let me delete all of this and then create again to show everyone about how to create it. Okay, so let's go. Okay, I will close all. This one I just create. Yeah, so first we need to have the software. Yes, PC sim and PLC sim. Okay, and then we can use the Step7 MicroWin. Yes, to create the program that we want to control. Okay, so let's open Step7 MicroWin, and then here I use the push button, right? Let's see the slide again. I0 for start forward, I1 for start reverse, I2 for stop, and I3 for overload signal. Okay, so let's create the program before simulation. So here I can use the NC for stop, right? So I 0.2. Yes, then I 0.0 is start forward, right? So I 0.0, and then Q 0.0 is start command forward, right? So Q 0.0, and then I will hold the signal also. Yes, when start forward, because we use just momentary buttons. Okay, so this one should be Q 0.0, and I will use SM 0.0 for use only one network. Yes, and then I will use the stop, right, and then start reverse, so I can copy and just change the address. Yes, like this. Yes, and then I will change 0.0 for start forward and 0.1 for start reverse, right? Q 0.1, and then hold Q 0.1, and then we need to use the safety contact for interlock between Q 0.0 and Q 0.1. Otherwise the power circuit will short if this contactor is on for the same time. Okay, so we need to use the interlocking contact. So I will use NC for overload. Yes, and NC for interlocking contact. Yes. So first overload, I will use I 0.3, right, in the slide. I 0.3. Actually, we can use here also the same. Yes. And this one should be used the auxiliary contact for safety contact, right? So Q 0.1 and here should be Q 0.0. Okay. So that's all for our program for word in reverse. So let's click here to export the program before simulation, because simulation support only .awl. Yes. So example, I say to keep on desktop. So FW RSE example forward and reverse. Okay. This is a file that we generate from the Step7 MicroWin. So we need to use the PLC sim, right? So open sim S7-200 sim, and its password should be 6596. Okay. So open here 6596. Okay. And then our CPU is 224 HP, right? So I need to change the CPU here. So double click and then change to CPU 224 XP and click as up. Okay. And then we can import, yeah, click here to load PLC from file that we generated in the desktop. So click as up, then choose the file FWRSE, right? Okay. And then click here and then we can minimize, right? Okay, we can zoom, yes, like this. And then we need to use another software that we call PC Sim. Yes. So let's go here and then choose the PC Sim, and password is 9966. Okay. So open here 9966. Okay. And then we can choose the push button, right? So I need to use the push button. This one is push button. For I 0.0 is start forward, right? So start forward is green color. Yes. So click here and then draw, yeah, for start forward. And then we can use take and we can key start forward. And we can click here, yes. We can use arrow key for adjust a little bit to align with the button. Okay. And we need to use the one more button for stop, right? So I 0.2 for stop. And then I will use the red color, right? This one, red color. And click OK. And we can draw, yes. Okay, like this. And we can use the text the same as before. So stop command. Okay, stop command. And we need to use one more button for stop, right? Sorry, for start reverse, right? So I need to use one more. And I 0.1 is stop button. Sorry, start reverse button. And I will use the green color also. Okay. And then we can use the text start reverse. Yes. And then we can click Okay, and I need to use the motor, right? So click the motor. Q0.0 is forward, Q0.1 is reverse, and then I will use 150 RPM, right? So click here, and then draw, yes, like this, and then we can use the text 3-phase motor, and we can click here, yes, right? So okay, so right now we can simulation. Okay, let's open the program and then click the simulation from here. Yeah, click simulation and then click start the PLC, yes, and then click here and then click online to monitor, yes, the status. So here I can start forward, yeah, when I push start, so push start, yeah, let's see motor is running forward, and let's see here the Q0.0 is turned on, and then our slide will contactor, this one will turn on, and then motor is run forward. Okay, so when I would like to start reverse, I cannot start because we need to stop first. Yeah, let's see here, I cannot start because we use the interlocking contact. Okay, so if I would like to start reverse, I need to stop first and then start reverse. Okay, so this is just example about how to use the software PLC Sim and PC Sim for PLC S7-200. Okay, and I hope this video just example for everyone to simulation. If we would like to simulation something for S7-200, we can use like this. So thank you very much for watching my video, and if everyone have any questions, please drop comment under my video. I will reply soon. And I'm so sorry if I have mistake in this video also, because my English is not so good. And I would like to request all of you to like, share and subscribe my channel also, to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to upload and download the program of PLC S7-200 by using PC Adapter MPI, yes, and use the software Step7 MicroWin version 4.0 SP9. Okay, and here is the PLC S7-200 CPU 226, and here is the power cable that I already connected 220 volt AC from the supply to the PLC terminals. Actually, we can use both MPI cable and PPI cable to communication between our PC to upload and download and modify or create the new project, upload and download to the PLC S7-200. Okay, so in this video I will show how to setting the MPI cable PC adapter to the communication upload and download program. Okay, So let's go to our software Step7 MicroWin version 4.0 SP9. Okay, here is the software Step7 MicroWin SP9. Yes. So let's open and then go to upload. Yeah, if we upload like this, it show error. Let's see, because we not yet set the communication. Okay, so let's click cancel first and then go to set PC interface here. But before go to this step, let's connect our cable PC Adapter MPI from our PLC to the PC. Okay, so if we not yet connect, let's see the driver of this module is not found. Okay, let's see, not found. So let me connect the cable. Okay, wait a moment for initialization for the first connection. Okay, so here is the connection that we can select here, because right now I use the visual machine. Yes, VMware player, so I use connect to visual machine. Yes, and then click OK, and around 10 seconds let's go to set PC interface again, and we will found the PC adapter here. Yes, PC adapter Profibus .1 active. Yes, the default of this software is PC PPI cable here. Yes, so if we choose the PC PPI cable, we cannot communication our PLC, because right now we connect to the MPI cable. Okay, so we must set the PC interface to PC adapter Profibus. Click here and then choose property, and here let's set checkbox to PC is only master here. Yes, and then for the baud rate, please take the baud rate is lowest. Yeah, here 9.6 kilobyte per sec. If we choose another baud rate, let's check. Okay, let open. Right now it's still communication between our PC with the PLC, right? Okay, so we must choose the lowest baud rate. Yes, that we can communication like this. I will choose 9.6 kilobyte per sec. Yes, and then click OK again, and let communication again. So wait a moment for communication. Let's see, here is found one CPU, address number 2, CPU 226. Yes, of PLC S7-200, and interface is PC adapter Profibus 1 via USB, and protocol is MPI. Yes, and click the CPU and then click OK. So we can press button down upload again. Yes, and I will save the project. Example, save to desktop. Example, MPI S7-200. Okay, I will press save, and then press upload to upload the program from the PLC to our PC. Okay, so right now we can upload from the PLC to our PC, and we can also online by press this button, and I will press start the PLC. Yes. Okay, so let's check here. We can communication between our PC with the PLC, and let me show the condition of the PLC. Okay, so let me show the condition of the PLC right now. Yes. Let's see the LED of MPI cable is blink blink. It means that we have communication, yes, between our PC to the PLC. Okay, and let's see the program is working. Yes, the same as the condition here. Yes. So this is how to upload. So if we would like to modify some points of program, we can also do. Yes. Example, I will add one more for Q 1.0. Okay, 1.0, right? So we can do also 1.0, 1.1, 1.2. Okay, like this. One more for 1.7, right? Because we have 16 bits for this one. 1.3, 1.4, 1.5, 1.6, and 1.7. Okay. 1.4, 1.5, 1.6, and 1.7. Okay, so we can please download. Yes, to download the new program to the PLC again, and we need to stop the PLC, right? During we download, we need to stop the CPU. Yes, let me show. Let's see, right now the CPU is running. So if I push button stop, yeah, button OK, it will stop the CPU. Yes, and then it will download the new program to the PLC. Okay. If I press OK again, after it download, the program will run again, and the new program will work. Okay, because we already modified. Last time we have only 8 bits of output is on and off. Right now we have 16 bits for output on and off. Okay. Or if we would like to change the timer to be faster than this, we also modify example 2 seconds. Yes, I will adjust counter to 2 seconds, and this one 2, this one 2 also, and then I can download again, and let's see the condition will faster than of output. Yes, we can test. Okay, let's see the condition again. So fast, right? It's so fast, right? So we can adjust everything that we want by using the MPI cable or PPI cable. Okay. Example, we would like to this output is 5, we can modify also. Yes, modify something like this. I will delete all. Yes. Example, I will delete this network. Okay, like this, and I will put SM0.5, yes, and then I can download. Yes, and run again. Let's see, the input is on, output is on very fast. Yes, let me show. Yes, on and off very fast, followed by our program. Yes, and we can online also. Okay, so we can online. So this is how to connect the PLC S7-200 by using MPI cable USB that we can do. Okay, and we can also start and stop the PLC from our computer by using the MPI cable also. Yes, and we also create a new project. Yes, example, we would like to create a new project, we can do also. Yes, new project, example, SM0.5. yes, example Q0.0. yes, we can also download the new program to the PLC by using this cable also. It's very important for set PG interface to communication between our PC and PLC. Otherwise, we cannot communication. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to upload and download programs from PLC S7-200 CPU 226 by using PC Adapter USB A2. Okay. So in the previous video, we already learned about how to communication, how to setting, how to download and upload the program of PLC S7-200 or create a new project by using the PC Adapter MPI. So today I will show how to setting for communication between our PC to the PLC S7-200 by using PC Adapter USB A2. Okay. Actually, this PLC we can communication for upload and download by using the PPI cable, MPI cable, and PC Adapter USB A2 cable. Yes, by follow the menu instruction and install the driver in the PC before make the communication. Okay. And I will use Step7 MicroWin version 4 SP9 and energize the power supply to the PLC 220 volt AC by connected from circuit breaker to terminal of the PLC. Okay. So to know the how to communication, how to setting, let's go with me together. I will show step by step slowly about how to communication for let everyone easy to understand about the concept and the setting. Okay, so let's go. Okay, so here is the software Step7 MicroWin version 4.0 series page 9. So let's open. The default of the software is communication by MPI, PPI cable. Yes. Let's see the communication. If we press this communication, we cannot communication because the cable that we already connected to the PLC is MPI A2. Okay, so if we try connect to the PLC by using the PPI cable, yes, we can communication. Yes, cannot communication. So let set the temporary PC interface. So let me connect the cable A2 to the PC and wait around 5 seconds. Yes. If we connect, let me show. Okay, right now I will choose Windows 10 Pro. Yes, 64-bit operation system. And if we go to see the device manager, yes, we will find the driver of this cable by go to device manager and go to the semantic net. Let's see, here is the driver of the semantic PC adapter USB A2. If I disconnect and connect again, let's see, here is not found, right? So if I connect again and choose this one, because right now I use the VMware player, so I will check the connect with virtual machine. Yeah, and let's see, the driver will show us. Yeah, it means that we already connected the cable between our PC to the PLC. Okay, so make sure, let's check here before make the communication and set PC interface. Okay, so we will back to our software again and go to set PC interface. Yes, and go to PC adapter USB A2 profit bus. Yeah, so click property, and here we need to check the PC interface is only master on bus. Yes, and then we must choose this baud rate. If we choose another baud rate, example like this 1.5 megabyte per sec, let me check and show to everyone. Yes, double click to communication. Let's see. Okay, let's see, the error is occur because the baud rate is not it means that not separate or not combination with the PLC, right? It's different. So we need to choose the baud rate to be the same as the baud rate of the PLC for support. Okay. So for my experience, I will use 9.6 kilobyte per sec for communication. And then let's check again. Yes, double click to communication again. So wait a moment for communication. Okay, so right now we will found one CPU 226. Yes, CPU of PLC S7-200 by baud rate 9.6 kilobyte per sec. Okay, So we must follow this step, otherwise we cannot communication between our PC to the PLC. Okay, so let's click OK, and then we can upload the program from the PLC to our PC by press this button, or we can go to the PLC and then go to upload, right? Okay, go to file and then go to upload, the same as the button. Yeah, I will test one by one to let everyone see. Yes, so we can upload. Okay, and we can also online, and I will start the PLC. Yes, so inside the PLC, it's just example, it has only this program. Yes, and then I can stop the PLC, and then I will show how to upload this bond. Yes, let me open again, and then go to set PC defect. Don't forget to check. Yes, here is already checkbox, and then check here, it should be the lowest of baud rate, and then please OK again, and then go to communication, and then double click to communication checking initial cable again. Yes, and it will found the CPU again, and then please OK, and then we can upload by using this button. Yes, and we can press upload button again to upload the program from the PLC to our PC, and we can also online and run the CPU. Yes, and we can also create the new program or download, modify this program. Okay, let me modify this program. I will add more for output. Let's see, there are 5 outputs. Yeah, example Q0.1, Q0.2, Q0.3, Q0.5, and Q1.7, because we have 16 bits for this output of this CPU 226. Yes, so let me download. Okay, so we can modify the program also. Okay, and we can online, and I will show the status. Let's see the LED of PC Adapter A2 USB is blink activity. It means that it communication with the PLC and PC. Okay, and let's see the status here is the same as the PLC work. Yes. Okay, so that's good for communication, and we can also stop first, and we can also create the new program. Let's go to this one, and the first one, don't forget check the PC interface to make sure we already check this one, and then the baud rate is lowest 9.6 kilobyte per sec, and make the communication. Yes, and then we can go to create the new program. Example stop start, example lamp 1, and it will hold the signal. Yes, like this. So this one example M0.0, M0.1, Q0.1, and Q0.1. Okay, so we can comment here. Okay, the first one is stop, right? Address M0.0, it is stop. Sorry, I will delete first. Go to here, yes. Symbol example stop. M0.0 stop one. One more is start button. M0.1, it is the start button, right? And one more for lamp one, Q0.0, it is the lamp one condition. Right, and let's go here and then we can compile. Let's see the description that we already created will compile, and then we can download because we already communication checking. Please download to download the program to the PLC, and then we can online and run the CPU. Yes. Okay, so if I force this one right to 1, it will on the output. Okay, let me show the output is on right now. Let's see the output 0.0 is on. Yes, so I will remove this one, so it will stop after I force on this one. Okay, stop, and then I will remove again. Okay, and then turn on again. Okay, turn off again. It still hold the signal, right? Because it hold like this. So if we can communication between our PC to the PLC, we can do everything like start and stop the PLC online, offline, or we can create the program, upload and download. So many function. So this one just example for everyone, easy to understand about how to communication between our PC to the PLC S7-200 by using PC Adapter A2 USB. Okay, so don't forget set the temporary PC interface. Otherwise, we cannot communication between our PC to the PLC. Okay, so don't forget this step. Yeah, choose the PC Adapter USB A2 profit bus. Go to property and check box this one, and then choose the 9.6 kilobyte per sec for baud rate. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to upload, download and create a new program for PLC S7-200 by using the cable PPI and software Step7 MicroWin version 4.0 SP9. Okay, and here is the power supply 220 volt AC that I already connected from the CB to the terminal of power of PLC S7-200. Okay, so it's very simple if we learn already about how to communication between PC Adapter A2 and MPI cable, and this one is very easy for communication. Okay, so let me show step by step about how to setting to let everyone easy to understand. Okay, so please follow me step by step. Yes, and if everyone have any question, please drop comment under my video. I will explain or make again for step by step. Okay, so let's go together. So here is the PLC step 7 MicroWin step 7 MicroWin version 4 SP9. So let's open. To communication, let me connect the cable, yes, PPI cable from my computer to the PLC. Let me connect, and then I will choose connect to visual machine because right now I use VMware player for this software. So let's check here and go to see the driver by go to here. Right now I will use Windows 10 Pro version 2018 and 64-bit for operating system, and go to the device manager to check the driver of this cable here. Yes, PC PPI cable. Yes, make sure this driver is occur, otherwise we cannot communication between our PC to the PLC. Okay, and then we will back to our software again. Go to if we don't set the PC interface, let's see, we can communication between our PC to the PLC. Okay, so if we install the software first time, we need to set the PC interface here to make sure we connect to the USB and choose the PPI cable. Okay, so it will error if we not config. To correct this issue, let's go to set PC interface and then go to PC. It show many driver, yes, that installed here. So let's choose PC PPI cable PPI .1 and choose property, and make sure we tick the USB, yes, not COM1. So we must choose the USB and click OK. And for the baud rate is here, yes, 9.6 kilobyte per sec. Press OK and double click here to communication again, check. Okay, it's still error, right? So let's try again. So right now we found one CPU detected by cable that connected from our PC to the PLC. It is CPU 226. Yes, so let's click OK. So we can press upload button to upload the program in PLC to our PC. Okay, and then press upload button again. And we will got all program from the PLC to keep in our PC. Okay, like this. Okay, this is a program inside the PLC, so we can online and offline, or we can stop the CPU, yeah, like this. Okay, and we also can modify the program. Example, I would like to modify the program. Yes, add one more example, SM 0.5. Yes, so we can control the Q, example 0.5. Q 0.6, Q 0.7, and we can download back to the PLC. And we can online and then run the PLC. So we will got the new program that we just download. Yes, let me show the actual. Let's see, the PLC is on and off the same follow as our program that we add inside the Step7 MicroWin. Yes. So this is a instruction how to upload and download, or we can also create a new program. Yes, example, I will create a new program. Okay, go to Step7 MicroWin and then go to communication again. Make sure our connection is communication is okay, and we can click OK. Yes. So example, I write timer on. Yes. Example T33. Okay, 10 seconds. This one example Q 0.0 or Q 0.7. Sorry, I will use NC. Okay. Then I will control the queue. (1.0) sorry, like this. Insert column, and this one should be always on. SM 0.0. T33. So when T33 is on, this one on, right? And it will on this one also. Q 0.7. Yes. Okay, let's test. Let me add a little bit timer. Example like this. Q 0.7. T34, yes, like this. And I will let T34 is reset T33. Okay, so we can download. And we can run the PLC. Yes. Let's see. It will on off and on off. Yes. Follow our program. So let me show the condition. Yes. The condition is on and off. Follow our logic that we already created. So we can do something if the communication between our PC is okay with the PLC. Okay. So this is just instruction how to link or communication between our PC to PLC S7-200 by using the PPI cable. We can upload, download, and we can modify the program, also create the new program for download to the PLC. Okay. So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you in next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC S7-200 CPU 224 HP CN, yes. And today we will learn about the expansion module, yes. In the previous video, we already learned about the analog input and analog output, and we already tested with the HMI also, okay, by using the PPI cable connect from the PC for download the program to the PLC and use the RS232, yes, for connect from the PLC to the HMI, okay. So in this video I will share more about the analog input expansion, yes. This analog input expansion we can call EM231CN, yes. That it include 4 channels of analog input, yeah, AI4, and it will be 12 bit, yeah. And this is a serial number, and here is the deep switch, yes, for select the option, yeah. If we would like to use input analog for voltage or milliamp, we must set this switch, yes. So I will focus on the drawing for the deep switch, yeah. And this video also I will test with the input for milliamp, yes, 0 to 20 milliamp, and there are 4 channels, yeah. This is channel number 1, number 2, number 3, and number 4, okay. So let's go to drawing, easy to understand. Yes. Okay, let's go to our drawing. EM232, sorry, 231, right? So this one, right? So here is the overview of drawing of the EM231 analog input, okay. Here is the channel, yes. And let's go to other parameter, yeah. Example for the deep switch. Yes, this one. And go to the deep switch. Yes, this is a deep switch here. Yes, so we need to configuration the deep switch. Example, we would like to use the 0 to 20 milliamp. We must select the deep switch number 1 is turned on, yes. Deep switch number 2 is turned off, number 3 is turned off, number 4 is turned off, number 5 is turned off, and number 6 is turned on, okay. So we will got 0 to 20 milliamp. Many function, yes. that we can select. Example 0 to 10 volt, 0 to 5 volt, 0 to 1 volt, or 0 to 500 millivolt, 0 to 100 millivolt, 0 to 50 millivolt. Yeah, we can use also. Okay, and this is unipolar, and this is a polar function. Yeah. So when we push on, yeah, it means that we turn on the dip switch. Yes. So let's go to our software to create more. Okay, I will explain this one more. So this is a analog input module, right? So here is the, if we connect it with the CPU 224 HP, yeah, it will start from AIW4 because this one start from AIW0 and W2 for build in the module, yeah, build in the CPU. So if we have expansion module, we need to continue from the last of the analog input terminals, right? So AIW0, AIW2, AIW4, AIW6, AIW8, and the last one AIW10. Okay, and we must supply the 24 voltage for this card also, otherwise it not work. Okay, so let's go to our software. Yes, to create some program for test. So I will use the existing project. Yes, this is the existing project that we already learned in the previous video. Yeah, so I will comment. Yeah. So we are learning about PLC S7-200 expansion module of analog input. Okay, so if we would like to test the analog input, right, so I will use the mover. Let's go to mover, and this one always on, right? So SM 0.0. So for example, this one is the output, right? So example VW6, and this one start from AIW4, right? And the last card, yeah, AIW10, right? So VWH, sorry, okay, VWH. So let's download. Okay, start the CPU and then online. Yes, right now I'm not yet provide the milliamp to the module. So let me provide some milliamp to the module. Yes. So I will provide 0 milliamp. Yes. Right now 0 milliamp. It error a little bit. Yes. Actually it should be 0 for this one. So I will adjust to 20 milliamp. Yes. Okay. 20 milliamp. Around 32,000 something. Yes. For AI4. Okay. So we will create the touch screen for show this signal also, right? So let's go to our software of touch screen. Yes. So I will use the existing project also. Yes. For this one. So AIW4, right? VW6, right? VW6. Okay. Correct. VW6. Okay, VW6. And AIW10 for VW8. Okay. So AIW10 VW8, yes, like this. And let's create the screen. Yes. This one AIW, right? I will remark. Example change to this color. AIW0 for existing. Yes. And I will copy this one for AIW. AIW4, right? Yes. And the last one for AIW10. Yes. AIW10. Yes. So VDC. This is a milliamp, right? Yes. Milliamp. Okay. So let's configure the text. Yeah. AIW4, right? And don't forget go here and then go to the scaling, right? So when PLC 32, yes, around 31, 9, yes, 985, yes, something, it will show 0 to 20 milliamp, yes, and this one also AIW 10, right? So go to scaling, 31, 985 something, it will show 20 milliamp also, yes, yes, and then save the project, and I will download this project to the HMI. So please wait a moment, I will start the HMI. So don't forget ping to make sure we connect to the HMI or not. 192.168.0.2.3. Okay, so we can ping. So let's go to download. Yes. Okay, right now downloading. Yes. Finish. Reboot. Yes. So we will go to the PLC and then online. Yes. Okay, right now I will adjust the milliamp for AIW4. Yes. Okay, here I connected the standard source, yeah, 0 to 20 milliamp to here, yeah, for AI4, or we can say channel number 1 of the expansion module, yes, and I will adjust, yeah. So let's go to see the touch panel. Yes. So right now I adjust to 20 milliamp, yes, and I will decrease, yes, 19 milliamp, 18 milliamp, yes, and you see the PLC, sorry, the status on the Step7 MicroWin is variable also, so I will adjust to example 12 milliamp, yes, like this, 10, yes, yes, like this, 0 milliamp, yes. So we will test the AIW, yes, AIW also for this one, and I will connect to this terminal, the last terminal, yes, this terminal. So wait a moment, I will connect. Okay, right now I already connected the standard source 0 to 20 milliamp to the last terminal, yeah. So let's test. So I will adjust the milliamp. Yes. You see the AIW10 is vary. Yes. Yes. 20 milliamp. Yes. So this is instruction how to connect the expansion module of PLC S7-200. Yes. And write some program for test. So if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again. Yes, today I would like to show and share about how to test and simulation the PLC Siemens S7-200 CPU 224 HP with analog output built-in. Yes. For digital input and other component we already discussed in the previous video. And this video I would like to share about the analog output module that built in this CPU. Normally, if we bought the PLC CPU 224 no HP, yes, it means that no HP, we don't have the built-in analog output. Yes, but when we bought the PLC 224 HP, we will got the analog output card that built in inside CPU. Yes, and it is the rank of the analog output. It comes from 0 to 20 milliamp and 0 to 10 volt. Yes, if we measure from this terminal to this terminal, it will generate milliamp from 0 to 20 milliamp. Okay, if we measure from this terminal to this terminal, it will generate from 0 to 10 volt DC. Okay, and the raw data come from 0 to 30,000, 32,000. Yes, 32,000. It means that when we source 0 from the software step 7, it will show 0 milliamp and or 0 volt from other terminal. Okay, so let's test together. So let's go to software. Here we can write move something. I will write again. Yes, here is the software Step7 MicroWin. Yes, I already connected the PPI cable. Yes, PPI cable from PLC to my computer already. Yes, and I already connected the cable of multimeter and select to milliamp DC, right? Okay, so let's write the program for test. So it is the word, so we will move word for test the analog, and I will write the always on for test. So always on SM0.0. Okay, here can press F1 and then search always on, can go to index SM. Yes, SM0.0 is the always on. Yeah, so I will move W, so VW 0 to we will move VW 0 to AQW 0, right? Because we start from 0. So let's download, compile and download. Okay. To download the program, first check communication. Okay, can check communication. I will disconnect again. Check communication. Why not come? Yes, we can download it. And then start the CPU, right? So right now the CPU is already start, so the value is 0 because we not yet set any real value to the move person AQW. So if we measure milliamp, right now we measure the milliamp, so 0. Yes, I will connect the multimeter to the terminal for easy to test. Okay, right now it's so 0 milliamp. Yeah, I will edit something, for example 16,000. Yes, 16,000 approximate 10 milliamp. Yes, I will increase to maximum 32,000. The milliamp is 20 milliamp, right? Okay, and I will change the multimeter to volt and then test the volt terminal volt for you. Okay, select 2 volt and measure the terminal volt. The terminal volt, yes. Yes, right now it's so 10 volt because the maximum of value. I will decrease a little bit, 5 volt, yes, 5 volt, and I will decrease to 0. It's 0 volt DC. Okay, increase again, example 5000, yes, 1.6 volt. Okay, so this is a instruction how to test the analog output of PLC S7-200 CPU 224 HP that it build the analog output in the CPU. Okay, so if we have this value, we can generate to control the some electrical devices. Example, VSD, transmitter, or actuator, or some electrical device. Okay, so thank you very much for watching my video, and in the next video I will show the scale, how to scale the analog input and output, and then test with the real PLC. Okay, so thank you very much again, and see you next video. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC S7-200 CPU 224 HP. Yes, and today we will focus about the analog input and analog output. So here is the drawing that I just draft for easy to understand. Yes, first here is the analog output, and there are 3 terminals, yes, for this analog output. First M, second I, and the third is V. So if we measure the M and I, yes, it will vary from 0 to 20 milliamp, yes. And if we measure the M with the V, we will find 0 to 10 volt DC, yes. And the raw data around 32,000, yes, from 0 to 32,000. And here is the analog input. There are 2 channels, yeah. First channel, if we provide the 0 to 10 volt DC for channel number 1, it means that this terminal M and A plus, it means that the channel number 1, yes, 0 to 10 volt DC, it will show the raw data around 0 to 32,000, yes. And this is a channel number 2, yes, If we provide the voltage from 0 to 10 volt DC, it will got 0 to 32,000 also for the raw data. Yes, and this is channel number 1 and this is channel number 2, and here is the address. Yeah, for address number 1 start from AIW 0, and for channel number 2 start from AIW 2. Yes, and the analog output also start from AQW 0. Yeah, so if we need the analog output with the voltage, we can use the terminal M with V. Yes, example, the VSD or some instrument or some electrical devices use 0 to 10 volt DC. We can jump from terminal M and terminal V to use. Okay, otherwise if the electrical device or some VSD, yes, use 0 to 20 milliamp or 4 to 20 milliamp, we can connect it the terminal M with the terminal I to use. Okay, so this is a drawing and concept or instruction that I just draft for easy to understand, and we will continue to see the overview of drawing. Yes, I will explain more. Yes, this is a drawing, all drawing of the S7-200 PLC. Yeah, especially for expansion modules. Okay, so let's go to the CPU 224 HP, right? Let's go to 224 HP. Yes, yes, here. So here is the drawing, overview drawing for CPU 224 HP CN. Yes, so it is the terminal for input, and this is a terminal for the output for analog, right? You see MIB, MA plus and B plus. Yeah, and this is a digital output and this is a digital input, right? So this is the other CPU. Yeah, HP SI CN. Yes, so let's go to our program to write the sample program for test. Yes, so I will use the existing project that we already learned in the previous video. Yes, so for this one, just test for digital. Yeah, and we already connected to the HMI also. So right now we will test with the analog input and output. So if we would like to write the input, yes, go to always on, right? So we can comment something here. Example, test the analog input and output of PLC S7-200 CPU 224 HP. Okay, so I will move it, right? So go to move it, yes, and this one it always M0.0, sorry, SM0.0, right? Always on. And for analog input, it will start from AIW0, right? For terminal, this one, yeah, this terminal M and A plus. And right now I already connect the standard source to these terminals also, yeah. So actually we can move to AQW, right? 0, okay, like this. So if we would like to connect it to the HMI, we can do also, yeah. So I will convert this one to the VW something first, yeah. If we would like to connect to the HMI, so we can use the mover, yeah. And this one replaced by this one, and this one replaced by VW, yeah. Example VW0, yes, like this. So we can create this value to the HMI, yes. So let's go to download, yeah, compile. Okay, error 0. So we can save our project and then download to the PLC, yeah. Right now I already connect the PPI cable to the PLC, so I can download, yeah. Stop the CPU, yes, and then run the CPU and online, yes. So right now I put 10 volt DC to the terminal, yeah, to this terminal, 10 volt DC, yes. Yes, 10 volt DC around 32,000, yeah. So if I adjust the voltage to 0, yes, actually it error a little bit, yes. Right now I put 1 volt DC, yes. So I will show how to test, yeah, after we create the HMI, yes. So right now let's go to create the HMI for show on the touch screen, yes. So we need to create the point of analog input and the analog output, right? So let's go to WinCC Flexible, yes. So let's go to open WinCC Flexible Smart, yeah, version 3 that we already learned how to configure and how to connect in the previous video. So let's go to open the existing project. Yes. So here is the existing project or existing value, existing screen that we already learned in the previous video. So let's go to text. Yes. So we need to create the analog input, right, and output. Okay. So example analog, or we can write AIW0. Yes. AIW0. It is the word, right? So AIW. Actually, we need to convert to the VW first, right? So example VW 2, and for AQW, right? AQW0. Example VW0. Yes. And save the project. And then go to screen. Yes. So let's go to the I/O, right? Yes. And mostly it is the integer. Yeah. So like this. And we need to adjust something, right? The middle, yes, like this. I would like to adjust the font here. So let's go to text, yeah. So AI, right? And we need to scale something, yes. Example show 0 to 10, yes, 0 to 10 volt, or 4 to 20 milliamp, or 0 to 20 milliamp. So we can convert in this scale. So AIW0 input, right? So right now input from 0 to 10 volt, right? So go here and then go here for scaling. So example PLC is, yes, 32,000, yes, something, example, or 31,985, yes. And the HMI will show 0 to 10 volt, example, like this. And then it okay, yes. So this one is the analog in, right? So I can comment analog input, yes. Analog input. So it is the volt, right? Volt DC. Yeah, the unit is volt DC. And I will copy this one, yeah. Example here. Milliamp, right? For output. Yes, milliamp DC. Right? So this is a analog output, right? So copy this one, yeah. Analog output. Output. Yes. Like this. And we will convert this one to the 0 to 20 milliamp, right, to show at the HMI. So AQW 0, yes, and go to points and then go to convert, right, go to scaling, and if PLC 0 to 31,000, yeah, 31,090.85 something, it will show 0 to 20 milliamp, right? Okay, so save our project, and then I will restart the HMI and then download to the HMI. Yes. Okay, right now I reboot the HMI. Wait a moment, yes, and click transfer, yeah, that we already learned in the previous video. So first I will go to command and ping to the HMI 192.168.2.3, right? So I can ping. So let's go to download, yes, download. Okay, right now downloading. Okay, done right now. And let's go to our PLC to convert, right, this one analog input VW2, right? So let's go. So I will convert the AIs, yes, to VW2. So I can copy, yes, AIW0, so VW2, right, to the same as our HMI. So compile error 0 and I will download again. Okay. Run the CPU and then online. Yes. And let's go to our touch screen and test. Yeah. Yes. So right now I provide 1 voltage. Yeah. If I provide 5 voltage to the PLC, yes, you see the milliamp is show 10. Yes, 10 milliamp, and the touch screen is so 10 milliamp also. Okay, and if I provide 10 volt, yes, 10 volt DC to the PLC, yeah, to this terminal, yes, and the output is 20 milliamp, yes, you see 20 milliamp, and the touch screen is show 20 milliamp also. Okay, so if I decrease to 2 volt, yes, 2 voltage, milliamp is 4, yes, 1 voltage example, yes, here is 1 voltage example, 6 voltage here, 6 volt, and the HMI is so 6 volt also, and the analog output is show 12 milliamp. Okay. So this is a instruction for create and test with the analog input and analog output of PLC S7-200 CPU 224 HP CN, yes, version 02.02, yes. And if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share my video, and subscribe also to get more new notification and more new video that I will create step by step. Okay, so in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC S7-200 that we will focus to the EM, it means that expansion module 235. Okay. In the previous video, we already learned about analog expansion module also, but the module is 231, yeah, that it has AI4 and 12 bit and no AQ. Okay, so today we will learn about the module, yes, analog output module and input module. We can say this one we can use both analog input and analog output. Okay, so first I will explain a little bit about the connection. If we connect this module to the CPU 224 HP CN, we can count from AQW4 from here, that we can use both voltage and milliamp for signal output. Okay, and for the onboard CPU, it also stick the analog output one channel also, that we can start from address AQW0, that similar to be here, yes. We can use 0 to 10 volt, or we can use 0 to 20 milliamp also. Okay, and for analog input on board, we can use 0 to 10 volt, 2 channels on board CPU. Okay, and when we connect it like this, for M is negative, yes, negative volt, or we can say minus, and here is plus voltage. Okay, and for expansion module, it start count from AI4, yes. Let's see here, AI0, AI2, AI4 until AI10. Okay, So if we connect it like this, we can use 10 channels for analog input and 2 channels for analog output. Okay. To easy to understand, let's go to our program to write program and test with the analog input of expansion module and analog output of expansion module, and I will test with the voltage and current also for analog output, and for input I will use only current, yes, for source the input. Okay. So before go to our program, I would like to explain more a little bit about the drawing of this module. Okay, so let's go. So to see the drawing, let's go here and then I will explain. Yes. Okay, here is the drawing of EM235 module, analog combination between 4 inputs and 1 output. Okay, let's see here. If we would like to use the volt for input, we can use only this terminal. Yes, we can connect from A plus and A minus. A minus is voltage minus and A plus is voltage plus. Okay, and if we would like to use the current, we can use 0 to 20 milliamp, but we need to jump this connection. Yes, jump this terminal also. That's why I connect the standard source to here, but jumping the terminal A and A plus. Okay, for plus milliamp. And for analog output here, M, you see M 0, it means that common, yes, between volt and current. If we would like to connect from here, we can use minus, and this is a volt 0 to 10 volt, and here is 0 to 20 milliamp. Okay, and here is the dip switch. Yes. Okay, I will explain a little bit for dip switch. Yeah, configuration. Let's see the dip switch. Yes, here configuration dip switch, and here is the gain. Yes, gain is adjust a little bit for analog, that accuracy is error a little bit, so we can adjust the gain and offset to be the same. Okay, so here, okay, let's see the EM235, right? Here is the dip switch. Let's see. If we configuration like this, we can use 0 to 50 millivolt. Okay, and if we would like to use the 0 to 20 milliamp, we can push this on, off, 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 off and on for dip switch number 1 and dip switch number 6. Okay, and if we would like to use 0 to 10 volt, we can off, on, off, off, off and on. Yes, like this. So the standard signal, we can use both. Yeah, we can use all of these by selecting the configuration dip switch. Okay, so let's go to our program to write program for test. Yes, the analog. Okay, let's go to Step7 MicroWin. Yes. Right now I use version 4 with page 9. Yes. Okay, to create the analog, let's see, write some command. Test analog input and output of module EM235, right? Okay, so I will use move. Yes, so before use move, let's see, we need to always on. Yes, so SM20 0.0 and choose the move word. Yes, so right now I already connected from the input from this terminal, so I will use the AI W4, and I already connected analog output AQW4 from this terminal. It means that current. Yes, and this one current also. So I will use AIW4 and then output AQW4. Okay, so let's go. So here I can use AIW4, yes, and move value to AIW4 also. Sorry, AQW4 also. Okay, like this. And let open. Yes. Check the communication port. Yes. Between my computer and PLC. Yes. Right now it found one CPU HP. Sorry, 224 HP. Yes. We are address 2 and baud rate 9.6 kilobyte per second. Yes. So let's click download to download the sample program to the PLC. Yes. Remote to. Okay, let communication again. Okay, and then let download. Error 2, error detect compilation. Okay, let me check why error. This one error. AIW4. Yes. Actually we need to compile. Yes, error 0, so we can download. Okay, downloading the program successfully. Okay, so let online and check. Okay, so I will adjust the milliamp from the standard source to, let's see, the current. Yes, in and out. Okay, so right now I will adjust the milliamp to 4 milliamp. Yes, 4 milliamp, the raw data around 6,000, a little bit. Yes. Okay, so let me adjust to 0 milliamp first. Okay, 0 milliamp. I will adjust the standard source to 0 milliamp. Yes, around 0.25. Yes, so it's not 0. Okay, so error a little bit because my standard source is not 0 also. So let's test. Okay, right now I already connected the standard source 0 to 20 milliamp here. Yes, and here is the analog output that I already connected from the multimeter to measure the current. Yes, you see current DC. Yes, and I will adjust the standard source. Yes, okay. You see the current is vary. Yes, current is vary. So I will adjust to 12 milliamp. Yes, 12 milliamp something. You see the raw data is vary also. If I adjust to 20 milliamp, yes, you see the output is vary also. Yes, 20 milliamp. Around 32,000 something. Yes, so it is okay. So if we would like to measure the voltage for analog output, we can use this terminal. Yes, okay, I will show. It should be 0 to 10 volt. Yes, let me show. So wait a moment, I will connect the multimeter. Yes. Okay, right now I will adjust the milliamp to 0 first to make sure it's 0 volt or not. Yes. Okay, it's nearly 0 volt. Yes. The range is 0 to 10 volt. So if I adjust to 20 milliamp, yes, go to 20 milliamp. Yes, the voltage is 10. Yes, right now 10 volt DC. Yes, so we can use both volt and current from this analog output by follow the dip switch. Yes, let's see dip switch here. Yes, okay. So this is an instruction how to connect and test the analog module of PLC S7-200 by using the standard source and measure the current and volt by use multimeter. Okay, and for this module we can also select the dip switch by using the configuration and adjust the analog by using this gain and offset. If it error a little bit, so we can adjust. Yes, so thank you very much for watching my video, and I hope this video will explain to everyone that use this PLC module. Yes, and I'm also sorry if I have mistake in this video because my English is not so good. So I'm also sorry if I have mistake, and I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. And if everyone have any question, please drop comment under my video. I will reply soon. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to use analog adjustment port of PLC S7-200, CPU 222 and CPU 223 XP. Okay, so for analog adjustment port, if we choose CPU 222, yes, we can use only one part of analog adjustment, okay, that we call SM28, yeah, for port 0. And if we choose the CPU 224 XP or another CPU, we can use two parts of analog adjustment that we can use port 0 for SMB28 and port 1 used for SMB29. Okay, so in this video I will show about CPU 222 first, okay, that we can use only port 0 for SMB28 only. Okay, so here is the sample program that I already created for show to everyone. Yes, but we can test together after I explain this presentation. Okay, so let's go to write sample program for test with analog adjustment for this CPU. Okay, so let's go. So first open Step7 MicroWin. Yes, right now I will use version 4 service page 9. Yes, for Step7 MicroWin. And for SMB28 is the byte memory. Yes, so basically we can use the byte memory. We can use move byte or something to get data from the CPU. Okay, so we can comment. We are learning about PLC S7-200 programming. Yes, analog adjustment. Okay, for CPU 222. Okay, so basically we can use always on. Yes, SM 0.0 is always on, that we will create the block for move the byte value. Yes, by data type. So to get data from the CPU, let's go to move. Yes, and use move by. Yes, and type SMB 28. Yes, it is the port 0 that we will get the data from port 0 adjustment. Yes, and here we can write VB because it by memory. Example VB 100. Yes, okay, like this, and we can compile. Yes, error 0. So let's download to the PLC and then start adjustment to see the raw value of SMB28. Yes, I will download to the PLC. Okay, run and then go to online. Okay, good. So right now you see the existing data that link from the CPU is 166. Yes. So if I adjust the if I adjust the port 0, okay, let me zoom a little bit for go to option and then zoom in. Yes, zoom in a little bit. Okay, online again. Okay, good. So let's see here. Is the existing raw value from the CPU 222? Yes. If I make adjustment, okay, I will make adjustment. So let me show the part that I will adjust. Okay, right now you see the port 0. Let me adjust the port 0. Yes, use the screwdriver, but adjust should be slowly. Yes, and let's see the data. Maximum data is 255. Yes, you see, right now is maximum. If I would like to adjust something, I just decrease. Yes, use the screwdriver for decrease. You see the value show 0. Okay. Okay. So if we would like to use this data, how to use? Okay, let me show. If I use this data to compare with the format to control some output, we can control. Okay, so if VB 100 less than, example 100 or 200, then I will turn on Q 0.0. Okay, so we can use comparison. Yes, if less than 200, right? So if less than 200, so we will use less than by, yes, 200. Yes, so VB copy and paste less than 200. Okay, then I will turn on. Okay, turn on output Q 0.0. Okay, if VB 100 greater than 200, then I will turn on Q 0.1. Okay, so if, okay, we can use greater than by and VB. Yes, VB 100 greater than 200. Yes, then I will turn on Q 0.1. Okay, like this. So we can got the value from the port 0 and then control the output of PLC. Okay, so let's compile. Okay, error 0, and then download to the PLC again, and then let's test again. Good. Okay, online. So let's see here. VB 100 less than, yes, it's so right now 70 swing something 69 70 something, yes, so less than 200, right? So it turn on output to 0.0. Okay, if I make adjustment, okay, I will adjust. Okay, right now you see the Q 0.0 is turned on. So if I adjust the port 0 again, if I increase, yes, you see the logic will change to start Q 0.1 because the value is greater than 200. Okay, you see. So if everyone would like to convert or do something, example like this, okay, I will example one more. If I convert this one, so I take convert from byte to integer, example, convert from byte to integer. Convert from byte to integer, yes. So I will use SM 0.0 for always on, otherwise we cannot compile, yes. So I will use SMB 28, and then I will use VB0, example VB0, sorry, integer V, integer, so please F1 to see, yes. Output should be VW, yes, or VD. I can use VW 0, yes, like this. Okay, so let's download again and see the value, and we can use the comparison or calculation from this value, so we can just adjust the value we can use to link another program from the port 0. Okay, so if I multiply, yes, if I would like to use the value greater than this one, I can multiply, yes. So go to math, yes, we can add more or multiply, yes, integer, you see. So VW 0 multiplied by 10, example VW 10, yes, like this. We can use another function to control the program that got data from the port 0 or SMB 28. Okay, let's see here. I just got only 255, but I can multiply by 10 and I will got 2550. So if I decrease, yes, I will decrease the value. Let's see here. is a vary also. Yes, you see. So this is a just example that we can use the port 0 of analog adjustment of CPU 222, yes, S7-200. Okay, so it's very important if we use this part, we can adjust the program inside the program by no need to connect with the computer or something. If we link the program, example adjust the timer or counter setting, we can do also. Okay, so I hope this video will got information to everyone, or new knowledge for everyone also that learn about PLC S7-200. And I would like to say thank you very much for watching my video, and I would like to ask everyone to like, share and subscribe my channel also to got new notification and new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue part 2 about how to use analog adjustment on CPU 222 and 224 XP ports. Okay. In the previous video, we already learned about how to use the analog adjustment for PLC CPU 222, and we have only one part for analog adjustment that we call part 0 for SMB 28. Okay, and here is the program that we already sampling or tested in the previous video. Okay, so today I will show the part 1 for SMB 29 of CPU 224 XP. Yes, about how to use the part 1, or we can create the sample program for test and adjustment for port number 1. Okay, or we can include port number 0 also for CPU 224 XP. Okay, so let's go to our program for create the sample and test adjustment for port 0 and port 1 of CPU 224 XP. Okay, so let's go. Okay, so first let's open Step7 MicroWin. Right now I use version 4 SP9. Okay, so let's start open. And first let's go to communication. Yes, click here for communication to check the communication between our PC with PLC. Yes, right now I already connected the CPU 224 XP and also power on. Okay, so right now the computer found one CPU 224 XP that already connected to the PC. Okay, so let's click OK. Yes, so to create the sample, yes, sample program, first I would like to write some command. Okay, I will zoom a little bit. So to zoom, let's go to tool option and then go here, yeah, program editor, and we can adjust example 16, yes. So here we can write command how to use unlock adjustment port 0 and port 1. Okay, for port 0 SMB28 and port 1 is SMB29. Okay, so first let's check the SMB28. Yeah, I will create sample program for SMB28 of this CPU. Because this CPU there are two ports that we can use. Yeah. Okay, so first let's use the always on SM0.0. Yes. And let's use the move by. Yes. It's similar to be the previous video also. So let's use move by. Yes. So move value and move by. Yes. For move by SMB 28, right? For port 0. And I can use VB0. Yes. And one more for move by. Yes. SMB 29 for port 1. Okay. Example VB 10. Yes. Or VB 50. Yes. Okay, so first let's test only this one first. Yeah, let's compile. Yes, error 0, and then I can download. Okay, start the CPU and then go online. Okay. So let's see, SM28 right now is 0 and SM29 right now is 225 maximum. Yes. So let me adjust the port 0 and port 1 and let's show the status of the PLC. Yes. Okay, right now I will adjust the port 0. Yes. And right now the port 0 is show 0. So I will make adjustment for port 0. Okay. Let's see, the value is vary, yes, from 0 to 255, yes, maximum. So if I adjust the port 1, let's see the port 1. Okay, you see the port 1 is vary also, yes, from 0 to 255 also. Okay, so we can use two ports. And if we would like to write some program for control the output, we can do also. Yes, let me show. If SMB 28 example less than 100, then turn on Q 0.0. Okay, so we can use move by. sorry, we can use the by, yeah, comparison. So less than 100, right? So less than 100, we can use less than by. Yes, and then example VB 0 less than 100. So I will turn on, yes. So we can use output, turn on Q0.0. Okay. And if this one, yeah, example for port 1 VB 50, yes. So if port 1 greater than yes, so VB 50 greater than 240, yes. Then the Q 0.0 will turn on. So this one should be and if Q and if SMB 29, yes, greater than 240, yes. So we can turn on the Q 0.0. Okay, we can write like this, or we can write like this SM0, sorry, VB0, and this one VB, because we take the output to control the program, VB 50, yes. Okay, so let's download the program and test again. Okay, let's see the program. So right now the Q 0.0 is turned off because the value of port 0 is greater than 100 and value of port 1 is less than 240. Okay, so first I will adjust the port 0, yes, to less than 100. Okay, so let's adjust. Okay, I will adjust. Okay, let's see. The condition 1 is turned on right now, true. And I will adjust the port 1 to greater than 240. Okay. Let's see, the Q 0.0 is turned on. Okay. So actually we can take this value, yeah, to convert or to adjust the timer something. Example, yes, I will show. Example, we can convert, yes, convert from byte to integer, then control the timer. Okay. Okay, so first we will use the port 0, yeah, convert the value of port 0. Okay, so convert from byte to integer, right, for control the timer. So byte to integer, and this one should be SM0.0 all the way on, yes. Example port 0 SMB0, sorry, SMB28 integer VW0, yes. So we can take from this one to control the timer, yes. Example multiply by 2, yes. So let's go to math and multiply integer, right? So VW0 multiplied by 2, yeah, example, and VW10. So we can take the value, yeah, to control the timer. Example, timer on, yes. T48, yes. Example T33, yes. And I will take from this timer, yes, this value to control the timer. So this one, if timer on, then Q0.1 is turn on. Okay, so I can use T33 and then output, yes, Q0.1, yes, like this. So to control the timer, we can adjust from the port 0 and then can delay time on and off. Okay. Okay. Timer, yes. Okay, I will use the command first. Example M0 for start, yes. Okay, let's download and test again. I just show everyone about we can take another value from the output of SMB28 of port 0 or SMB29 from port 1 to control another program that we want. Okay, so right now I would like to control the timer followed by adjustment from analog, yes, to control the output to 0.1. Okay, so let's test again. Okay, so right now you see the timer is actually we can use this one for control the timer, yes. I can take from M0.0 for command start. Otherwise the timer is turned on, yes. Okay, so let's download again. Okay, good. So online Okay, let's see here. SMB28 just 81 and then multiply by 2 equal 162. Yes. So if I adjust the port 0, yes, if I adjust the port 0 to be like this, yes, and then start the M0, yes, 0.0. Okay, I will write on. Let's see, the timer will turn on. Yes, you see, turn on immediately after the timer is equal the value that we adjust from the analog. Yes. So if I turn off and then adjust the SMB28, it means that port 0 again. Yeah. I will adjust to maximum. Okay, 255 maximum. And then I will turn off. Sorry, turn on again. Let's see. The relay time is bigger than before. Yes, because I adjust to maximum. Okay. So this is just a simple program that we can take the value from the SMB28 or 29 to use with control the some program that we want to use without modify the program inside. So we can modify the timer by adjust the port 0, then it will affect to the Q0.1. okay, delay time for start. So thank you very much for watching my video, and I hope this video is just example for everyone that like PLC S7-200, yes, programming. And if I have a mistake in this video, I would like to say sorry, because my English is not so good, yes, but I would like to share about the knowledge that I have to everyone. Okay, and I would like to request all of you to like, share and subscribe my channel also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to use the clock pal memory in PLC S7-200 CPU 224 XP. Okay. So before go to write the program for test with the clock pal memories, I would like to explain a little bit for that two function. So first, when we use SM0.4 clock pal memory, it means that it will turn on 30 seconds and then turn off 30 seconds. For duty, cycle time 1 minute. Okay. And if we use SM0.5 clock pulse memory, it will turn on 0.5 sec and turn off 0.5 second also. Okay. On cycle time 1 second. Yes. So it very fast if we use SM0.5. It will turn on and off within 0.5 second on cycle time 1 second. Okay. So we can use the clock to count the counter. Example, count every 0.5 second. Yes, I will show you on the program. Yes. So to understand this function, let's go to create the sample program and test with me. Okay. So let's go. Okay, right now I will use Step7 MicroWin version 4 with page 9 for create the sample program for test. Yes. And we will use SM0.5 for count the counter, right? Okay, so let's go. We use SM0.5 for count and then control the output. Yes, Q0.0. Yes, so we will use SM0.5, right? And we will use the counter up. Yes, example counter up C0. Yes, example 20. Yes, and if equal 20, we will turn on the output, right? Okay, like this. Turn on the output. So if equal, yes, equal integer, because it is integer for counter, right? So equal integer, yeah, comparison equal integer. Yes, equal integer, yes, this one. So if say 0 equal 10, yes, example equal 10, and I will decrease this one to 50. Then I will turn on one output. Yes, example Q 0.0. Yes, and then I will hold the signal. Yes, so Q 0.0 will hold the signal, and then after this one turn on, I will reset the counter. Yes, so NO, we will use NO for reset. Q 0.0 turn on, it will reset the counter, right? And it will cycle time. Yes, so we can use the NC, yes, contact. Yes, NC contact for say 0. Yeah, like this. So let's see the condition. Yes, and we can command this one. If say 0 equal 10, then Q0 dot 0 will turn on. Okay, so let's see. I will show SM0.5 first, and then we will test SM0.4. Yes. Okay, so let's start the CPU and see the condition. Yes. Right now you see it will turn on and off every 0.5 second. Yes. Oh, reset. We will use like this. Say 0. Okay, like this. If this one turn on, it will reset. Yes. Reset the counter, right? So I will use the like this. 10, right? So I will use 20. Yes. Example set to 10 like this. So maybe I will use say 0 for reset. Okay, let's test like this. You see 5, 6, 7, 8, 9, 10, 12. Okay, the output is not turned on because we use the counter 10. Sorry, counter number 0 is equal 10 also, right? So if I use like this, maybe I will use like this. Automatic reset, right? So cycle time, I will send one PAL for reset the counter, right? So if the Q0.0 is turned on, I will use like this. P, yes, positive. I will use the positive, yes. Positive contact. For reset the counter, yes. I will increase this one to 20. Yes, let's see the progress. 3, 4, 5, 6, 7, 8, 9, 10. Okay, lock, and it will reset, automatically reset. Yes, yes, 10. And we can also use this function like this. If counter equal like this, yes, if counter say 0 equal 15, yes, example equal 15, then reset the counter, right? Okay, reset the counter. So I will use internal memory, example M 0.0, and then I will use M 0.0 for reset the counter. Yes, and let this one is free. Yes, yes, M 0.0. Sorry, this one equal 15. Yes, I will stop Q 0.0 and then reset the counter also. Yes. Okay, let's see the condition. So first I need to reset the counter first. Yes. 2, 3, 4, 8, 9, 10. Okay, turn on, and then after 15 it will reset. Yes, reset, and then it will cycle count continue. Yes. Okay, this one for SM 0.5. Yes, turn on 0.5 second, turn off 0.5 second. So right now I will use one more for SM 0.4, right? Okay, so SM 0.4 we can also create the program. Yes, so SM 0.4, it means that it will turn on and turn off every 30 seconds. Yes, so I will use I will turn on the Q 0.1 every 30 seconds. So if CPU turn on, then Q 0.1 will turn on every 30 seconds and turn off every 30 seconds also. Okay, so I will download. Okay, let online and check the condition. Yes, right now you see the Q 0.1 is not yet turned on because it will turn on 30 seconds and then turn off 30 seconds. Okay, let me show. Right now it was turned on. Yes, I will show the condition on the PLC. Yes, yes, it will turn on and off every 30 seconds. For Q0.1, yes, turn off. Yes, turn off. For Q0.0, it will turn on and off every 10 seconds. Yes. Yes. Okay. You see Q0.1 is turned on again. Yes. So this is just additional function that has inside the CPU, yes, of PLC S7-200 that we want to use the clock memory for control the other program, yes. For the case example, if we would like to use it for example faster than this one, we can set 5 and then reset example 10 reset, so it will go faster than this one. Yes, let's see the condition. Yes, okay, every 5 seconds it will turn on and off. I will reset the counter first. Okay. Yes. Let's see, the condition is faster than before. Yes. Every second, 5 seconds, it will turn on and off the Q0.0. Okay. So I hope everyone will understand about this video about clock memory, PAL clock memory on PLC S7-200 CPU 224 HP. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you in the videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue about how to connect the Keypad TD400C to a PLC S7-200 CPU 224 HP. Okay. In this section, I would like to explain a little bit about how to connect from the keypad to the PLC, and then how to create the program or wizard for this keypad inside the program Step7 MicroWin version 4 SP9. Okay. So I will use the PPI cable for connect from my PC to the PLC by using one port, and another port I will connect to the keypad TD400C, yes, version 2. For create the sample program or wizard, Let's go to our software Step7 MicroWin version 4 series page 9 together. Yes, so let's go. So first open software Step7 MicroWin, and then let's go to Tool, Text Display Wizard, or we can go here. Yes, Wizard tab, and then choose the text display. Yes, the same. Let's see here, the same. Or I can go to Tool and then choose the text display wizard. Okay. Click here and then let's click next, and then choose the display keypad that we want to connect. For my keypad, I use TD 400C version 2. Yes, here version 2. Then click next, and click next again, and click next again. Here we can use the language that we want. For me, I use English, and then click next. Here is the function that we will choose. Example, we would like to use the key, yes, from F1 to F8. Yes, we can specify here. Let's see the picture. It starts from F1 to F9, F10. Yes, so we can choose the function that we want. Example, F1 set bit. Set bit is the hold the signal when we press. So if I would like to use the momentary contact, I can change. Yes. Right now I change the F1 and F2 to momentary contact. It means that when we press and release, it will turn on and off. Okay. So another key we can choose here. Okay. So click next again, and then here I will create the status of the motor. Example, motor running, motor stop. Yes, when we press F1, motor is running. When we press F2, motor is stop. So we can define in the software also. So to create it, let's click alarm. Yes, and then click next. Then choose a full screen of text and click yes. Here is the text that we want to show on the screen of keypad. Yes. Example, I will choose motor status is example running. Yes, for alarm 0. And if we would like to create one more alarm, we can click new alarm, and then we can use motor status is stop. Yes. So we click OK, and then click next, and then click next again, and then click finish and yes for confirm. So the next step, we will create the program that link with this button F1 and F2. for start and stop the condition of motor. Okay, so I will use the SM0.0. Yes, for I use only one network for start and stop and show the status of alarm. So I need to use the SM0.0 for always on. If everyone would like to understand more about the SM, we can press F1. Yes, and let's read it. What is the function of F1? Sorry, SM0.0. Yes. So I can use the stop button, start button, and for the coil, yes, for status of motor and alarm. So example, I will use F1. Yeah, so right click here and then choose select symbol for choose the function of the keypad that we want. Okay, so I can choose F1 for stop. Yes, and F2 for start. So select symbol and choose F2 for start. And then I will hold the signal by the alarm. Yes. So I will use alarm 1, sorry, alarm 0 for motor status start. Yes, that we already setting up. And then hold the signal. Yes, I will hold the signal. So I will choose the alarm 0. And here is the output that we want to start the contactor or relay to control the motor. So in this case, I will use Q0.0. Yes, for start the motor. And then I will use the alarm when stop. So I can use NC. Okay. And then choose the F0. Yes. So when alarm 0, when alarm 0 is turned off, it will show motor is stop. Okay, so I will choose alarm 1 for motor condition stop. Yes. Okay, so let's compile. Okay, error 0 right now. So right now we already create the sample program for freeze the F2 for start and F1 for stop, and also show the condition of start and stop the motor on the keypad display also. Okay, so this is how to configure or wizard the display. So let's download the program to the PLC, and then it will link automatically from the port. Yes, from this port to the keypad when we connect cable to the port of the keypad. Okay, so let's download. And then start the CPU. Yes. Okay, let's see here. Right now the motor should be show condition stop, right? Because alarm 1 is turned on. So let me show on the keypad. Okay, let's see right now the motor status is stop. Yes. So if I would like to start, I just press F2, right? for start. So when I press F2, yes, let's see motor stator is running. Okay. So if I would like to stop, let's see the PLC also show the condition also. Yes. Yeah. So if I would like to stop, I just press F1 for stop, right? That we already configured. Yes. So the motor show status stop. Okay. Start again and stop again. Yes. Start again. So I hope everyone will understand about how to reset or write a program for connect with the keypad, yes, of the TD that we want. Another version we can choose from the wizard that I will, sorry, I already show before, yes. So it's very important for we use keypad or touch panel that we can link the data or show the data like show alarm in the display of keypad or HMI by using PLC S7-200. Okay. So thank you very much for watching my video. And if everyone have any question, please drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video also, because my English is not so good. Yes, and I would like to request all of you to like, share and subscribe my video also to get more notification and more videos that I will create step by step. So in this time I would like to say goodbye and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to increase and decrease the value, yes, of keypad, yes, by using PLC S7-200 CPU 224 XP and use the keypad TD 400C version 2, yes. Basically, if I press F1, it will increase the value of some memory. It is just example, yes. For the practice, we can use another memory that we want. Example, increase the byte memory, increase the word memory, yes. So when I press F1, it will increase this value. Press F2, it will decrease this value. And if I want to reset, I just press F3. Yes, it will reset this one to 0. Okay. So let's go to software Step7 MicroWin version 4 CV page 9. I will show how to reset the display of TD 400C version 2 and connect to the PLC. Okay, so let's go together. Okay, so first open the software Step7 MicroWin and then go to the tool and click the text wizard, or everyone want to go here, you can also go to wizard tab and then click the display, yes. and then click next and choose the display, the keypad that we use. Yeah, and please let make sure the display type and the version, the actual version that stick on the keypad. Okay, so in this case I have keypad series TD 400C version 2, so I click this one and then click next and click next again, and we can also choose the language that we want, but right now I will use English language. Yes, and here we can change the option. Example, we would like to use the set button, we can use the default, and for I would like to use the momentary, I just change to momentary for F1, F2 and F3. Yes, and then click next, and I will use the display, right? So no need to use the alarm, so I use the display. So click user menu and then click next, and this one we just put the name of the screen, example test screen. Yes, and then click add screen and then choose yes for add the screen. Here is the screen that we would like to show on the keypad display. Example, the value or value of VW. Example 10 equal, yes, or like this. So here we can choose the address that we want to show here by insert PLC data. So here I can choose VW10, yes, and click sign or unsigned integer that we would like to use. Right now I will use unsigned, yes, unsigned, and then click next and next again and next again and next again and click finish and click yes. Okay, so right now we already wizard the text display. Yes, so we need to call this, yes, to the main program. Yes, otherwise it's not working. So to call the block of display to touch panel, let drag and drop here. Yes, we can use both of it. Yes, and I will use SM 0.0 is always on, so SM 0.0. And if everyone would like to know clearly about what is the SM 0.0, can click please F1 and let's search here. So I can search SM, yeah, and then enter. So you can use another SM that we want. SM 0.0 is always on, 0.1 is on, first scan, 0.2, yes. Many SM that we can use for internal, yes. So I will choose always on, and maybe alarm no need to call, yes, because we not use it. And here I will choose the key, right? F1 for increase the value, F2 for decrease the value, and F3 for reset the value, right? So I can use from here. example, I will increase. So I will choose F1. Yes. Right click on the address and then choose the select symbol. And then choose F1. Yes. And we need to use the positive edge contact, right? Otherwise, the value will count very fast if we press. So we need to use the positive edge. And then I will use the function, yes, increase vert. Yes. And vert is the address that we fix on the wizard. Yeah. So VW10. This one VW10 also. Yes. And I will use the F2 for decrease, right? So F2 for decrease. And I will use the positive edge contact also. And then I will use one more function for decrease, right? So DEC increase vert because it is the word memory. So VW10 also. And one more for reset, right? So I will use F3 for reset. So I can use like this. This one we no need to use the positive edge contact because we just reset, right? So here I can move it. Yes. So move it. And then I will use F3. Yes. For reset the value of VW10. So I can move 0 to VW10. If I press, it will move 0 and then reset to 0. Okay. So let's compile our program. Yes, error 0. It means that no error occur. And then we can download. Yes, click download and then stop the CPU. And then online. Yes. Okay. And then let's see the HMI. Sorry, let's see the display and keep it. Yes. So here the value is so 0 for VW10. So if I press F1, it will increase, right? Let's see, it will increase step by step. If we press like this, it also not count because we use the positive edge. Yes. And if I would like to decrease, I just press F2. Yeah. For decrease. Yes. And if I would like to reset, I just press F3 to reset to 0. Yes. Again. Increase again. Yes. Decrease again. And reset. Okay. So we need to use the positive edge. So let me show a little bit. If we not use this contact, what happened? Yes. I will show. Okay, I will clear first. Yes. So let me show what is different between we use positive edge and not use. So if I freeze, let's see here. Yes. the value is count very fast if we use the positive edge. If we not use, sorry. And if we decrease also fast, very fast. Yes. So we need to use the positive edge contact. Yes, that's why I use the positive edge. So positive edge contact, yeah, and then copy and then paste, yeah, and then download. So this is just example to show everyone about how to link or increase and decrease the value when we use the keypad. Yes, TD400 version 2. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video also, because my English is not so good. Yes. And I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about basic PLC S7-200 Siemens programming, that we will use the level radar to measure the water inside the tank. Okay, and here is the PLC S7-200 CPU 224 HP, and here is the expansion module EM231 that has analog input 4 channels. Yes, and the concept is we will show the value of the water in the touch screen. Yes, by using the level radar for measure the water inside the tank, and then transfer the 4 to 20 milliamp signal to analog input of PLC. Okay, so first we need to convert the signal from 4 to 20 milliamp to 0 to 900 liters. Okay, and then we will create the screen by using WinCC Flexible. Yes, to download to the HMI for show the water level water, sorry, in the HMI. Okay, so we need to use the two softwares. First we need to use Step7 MicroWin, and second we need to use the WinCC Flexible. Okay, by Step7 MicroWin create the scaling for control or measure the water, and WinCC Flexible for create the screen for show the level water in the HMI. Okay, so let's go to our program of MicroWin. Yes, Step7 MicroWin first. Okay, so here we need to use the two functions. First, scaling because this PLC has only 0 to 20 milliamp, but our live radar, yes, is 4 to 20 milliamp. Okay, so we need to converter, and here is the scaling block that we already learned in the previous video about how to create the scaling. Yes, here is the block scaling that we already learned and created in the previous video. Okay, so we need to convert from the lower rank of analog input. Here is the lower rank that I already tested of my analog input card of PLC for milliamp around 5,000 something, and for 20 milliamp around 29,000 something. Okay, so first we need to convert from analog, from integer to double integer, because AIW4 is integer value that provide from live radar. Yes, so we need to convert to real. Yes, so double integer convert to real, and then we can get the memory real to here, scaling, yes, to this block, yes, scaling block, and then we will generate the output, yeah, to analog input block. For analog input block, we also learned already in the previous video. Yes, for convert from analog input to the PV. Okay, so we just drag and drop this block from the subroutine, yeah, to use, and here is the raw value that provide from the scaling, yeah, here MD10 you see, and here is the high scale. Right now I set 900 lira, yes, you see our tank is 900 lira. So high scale I will set 900 lira, and for the low scale I will set 0, and here is the alarm set point. Example, we can set 850 lira for alarm high, and high is 800 lira. For low we can set 100 lira, and low alarm we can set 50 liras. Okay, and here is the output that we take it to show on the HMI, yeah, and here is the alarm, yes, the alarm, high alarm, low alarm, and low alarm. For this block we generate from here, yes, that we already learned in the previous video. So I'm no need to create again, we just use this block. Yes, okay, so if everyone understand, I will go to download this block to the PLC. Yes, so I click download. Yes, download the program to the PLC, and then I will start the CPU and online. Yes. Okay. So right now I select milliamp to 12, so it will show around 500 liters. Yeah. If I adjust, yes, right now 4 milliamp. Yes, it's 0 something. Yes, swing a little bit. So we need to create the program on the HMI to show this value. Okay, so let's go to create. So first open the WinCC Flexible software. Yes, and then create the empty project, and then go to the panel, choose the touch panel to match with our HMI. Okay, so we right now I use TP 170B 6-inch color for my HMI. So I click here and then I click OK. Okay. So first we need to create the connections. Yeah. Example HMI one. And then I will connect to S7-200. Yes. And here I can use the DP. Yes. And here is the port interface of HMI, and here is the address of the PLC. Yes. So I can use the baud rate. Yes. 9600. Okay. After the let's go to create the text. So example water level. Yes, it is the real, right? And the address is MD20. Yes, so MD20. Okay, we can comment level of water. And one more for alarm, right? Alarm high, low, and low. Yes. So it will start from Q0.0. Okay. So alarm, high alarm, high ALM. Yes. It is the Boolean, right? So Q0.0, high alarm. One more for low, sorry, high alarm. Yes. One more for low alarm. ALM. Yes. The last one for low alarm. So LLALM. Yes. Right. Okay. So right now we already created the text. So let's go to screen and then go to our graph. Yes. To insert the tank. Yeah, one tank. So go here, graphics, and then go to go here and then go to the tank. Yes. Okay, so let's choose one tank for okay, so right now I will use this tank. Yes, so drag and drop the tank to our screen. Yes. Okay, like this. Okay, so we need to create the color. Yes, when the water up and down, right? So I will use the bar. Yes, like this, and we can adjust. Yes. Okay, so it is the water tank. So to adjust the scale something, let's go here and then property. Yes, right click and property. So I need to adjust this one to 900 lit, right? So 900, it is the scale, and here is the color. When the water up and down, it will show in here. So go to general, go to property. Yes, you all. Yes. So in apparent, we can change the color. Yes, overall I will choose the color. Yes. So scale we already put it, and this one we need to choose the text. Yes. So the text that we need to use, we need the water level, right? So go to the screen and then select the water level. Yes. Actually, we need to show the value of the water also, right? When we create like this. So I need to put some text, sorry, some IO file. Yes, output only, and the text is water level also, and I will use, yes, 999 because our rank is only 900 liras. Yes, and go to property, go to adjust the font size. Yes, center, middle, and I will use the black color, and the text is green. Yes, so I can write water level. Yes. Okay, and then I will copy one more for water tank. So water tank. Okay. and then I will create the alarm, right? So like this, and I will copy 4. So example, this one is high alarm. Can write like this, high alarm. Copy 3 more. Yes. So this one is high alarm, right? This one low alarm. And the last one is low alarm. Okay. So I need to show this one, and this one when the alarm is appear. Follow our set point here. Yes. So I will change to red color for high alarm. Yes. So here I can choose the text. Yeah. HALM for high alarm. And when it won, it will change to red color. And then flashing also. Okay. And visible, I will no need to hidden. Okay, like this, just like this. And this one for high ALM. Yeah, high alarm. So I will use the, oh sorry, not use this one, we use animation. Yeah, high alarm. When it on, yes, it will show yellow color. And then no need to flashing. Yes. For low, yes, low alarm also when it on, it means that it on. I will show the yellow color also, and no need to flashing. And when it low alarm, yes, I need to change the color also, red color, and then flashing also. Okay, good. So save our project. Save to desktop first. Create the new folder. Water tank. Okay, so I will simulate first for let's see the screen before we download the project to the HMI. Yes. Okay, so it will show like this if we download to the HMI. Yes. So this one unit is lit, right? So I will copy one more for lit. Unit is lit. Good. Okay, like this. So save our project and then download to the HMI. Yes, download the project to the HMI. Right now I already connected the cable from my PC to the HMI via COM3. Yes, let's check the COM port. Okay, right now I use COM3, so download to the HMI. Okay, right now downloading the project to the HMI. Okay, it was done right now. So let's go to see our project of Step7 MicroWin. Okay, right now it show 0 liters. Yes. So if I adjust the milliamp, yes, because right now I already connect the cable to the analog input. Yes, here this part. Yes. So if I simulate the signal, yes, right now 8 milliamp, 12 milliamp. Yes. The color of the border tank is not yet correct, so we need to adjust a little bit. Yes. So let me adjust the screen. Yeah. So here go to general. So we need to change this text to here. Yes. I will delete this one because it is the process, so we need to put the text here. Yes. And then I will download again to the HMI. Yes. And let's see the result again. Right now it downloading. Yes. Okay, it was done again. Okay, let's see. Right now it show 900 liters. Yes. So if I adjust milliamp, yes. Right now 8 milliamp. Yes. 12 milliamp. 16 milliamp and 20 milliamp. Okay. So it error a little bit for the value that show in the HMI. So when I increase to the maximum, it will show the alarm high and high. Yes, because the alarm that we setting only 850. Yes. So this is a example for convert from the milliamp to the water tank level. Yes, that we can increase here. If we would like to change something, we can first test the analog input 4 milliamp and 20 milliamp, and then put the value here, and we use to create the analog input block. Yeah, here for this scale we can use another rank that we want, example 10,000 lira or something we can use here. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. For in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to control the motor automatically with the level of water by using the PLC S7-200 analog input module. Okay. In the previous video, we already learned about how to use the PLC S7-200 analog module for measure the water in the tank, inside the tank. Yes, and we already show the level of water in the HMI also. Okay, so in this video I will use the existing project and just add one more for motor pump for control the level of water. The concept is when the level is low, then the pump is turned on, then the level water is high, then the pump is turned off, following our set point, the high and low from the HMI. Okay, so let's go to our program of existing project to create one more for interlocking for control the pump. Okay, so I will use the existing project that we already learned in the previous video. So I will download the existing project to the PLC after we revise the interlocking of the pump. Okay, so to control the pump, we will need the alarm. Yes, for low and high to control the pump, right? So let's create for interlocking. I will change this one to M because we need to use the Q for control the contactor or relay for control the pumps. Okay, so I will use M, example 10.0, M 10.1, M 10.2, M 10.3. Yes, so if If M10.2 is turned on, yes, low alarm is turned on, then it will start the motor, right? So start the motor. I will use 0.0 for start the pump, and then I will hold the signal when the pump start. Okay, so hold by Q 0.0. Then if the if the level water is high, yes, I will delay a little bit, then will stop the pump. Okay, so I will use the timer. So when M10.1 is on, yes, it means that high level. Then I will use timer. I will use timer on. Example T33. Example 10 seconds. Then I will stop the motor. Okay, stop the pump. So this one should be T33, right? T33. Then we need the set point high, low, 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 and high, high from the HMI, right? So we don't need to fetch this one. We need to vary, follow set point from the HMI, right? So I will use memory, yes, AC0, AC4, AC2, AC4, AC6. It is the real value, right? Low alarm set point. AC. Okay, let me check. We can use another memory that we want. Yes. So input we can use VD. Yes. I will change to VD. VD4, VDH, VD12. Then the output still use the MD20. Yes. Let's compile. Yes. Error 0. So I can download to the PLC. And then we will create the WinCC Flexible project to set point and see the pump start and stop from the HMI. Okay. So let's go to WinCC Flexible. So we need to create the text first, right? for control the pump, and set point high, low, high, and low from the HMI. So this is a existing project, yes. So I will create the text. So we need to create the high set point, right? High alarm set point. It is the real and start from VD0. High alarm set point. High alarm set point. ALSP. Low alarm set point, right? Low ALSP. And low alarm set point. ALSP. Low alarm set point. And we need to show the pump status, right? So Q 0.0 pump running. It is the boolean, right? So Q 0.0 pump running signal. Okay, then we can create the screen. Yes, I will delete the alarm, yes, because we not use it, and then instead by alarm set point. So I will use IO file. It is the input only, yes, for alarm set point. So ALM high alarm set point, right? And copy one more for high alarm set point. Copy two more for low and low alarm set point. So low alarm set point, then low alarm set point. Okay. Property, we can use the text color for green, and then use the black color for background. Yes, and then we can insert the pump. Yes, let's go to insert by go to the library, and then go to the graph page, go to the symbol, this one. Yes, and go to find the pump. Yes, let's select the pump that we want. Yeah, example, I select one pump. Yes, this pump. Zoom a little bit. Yes, it has so many pumps that we want. Yeah, if everyone want to use the pump or motor, we can use from here. Yes, this is the motors. Yes, so many graphics that we can use. Okay, so I will let adjust this one to the top, or we can put here. Yes, put like this. Yes, and then we can adjust this one to the top also. Yes, so this one is the alarm, high alarm set point, right? High alarm, high SP. Copy for, then we use to align. Yes, so this one should be high alarm set point. Then we can align. Yes, and we can use the stator pump, right? So I can use the rectangle for show the status of pump. And then go to color animation apparent and then choose the text pump running and choose the bit. So we can change to color green when the pump is running, and the normal should be red color. Yes, like this. And then we need to use the polyline for pump the water. Yes, we can adjust the pie. Yes, change color pie like this. Okay, it is just example. Yes, if pump running, the motor will change the color, and then the water will pump to here. Yes, so let's download to the HMI. Yes, and then we will see the status together. Yes, it was done. So let's see the screen, and then we will adjust the high, low, and low alarm set point. I will adjust this one a little bit for function, okay, for a line to be the center. Middle, and for the format we can use 1000. Yes, and then download again. Yes, okay, right now it's downloading the project to the HMI. Yes, okay, let's see here. So right now we not yet set point the high and low alarm. Yeah. So let me set point. Example low, I will set 100 bit. Low 250 bit. High example 800 bit. And high 900 bit. Yes. So if I adjust, let's see, right now the motor is running because it low. Data is 225 bit, but the low that we set is 250 bit. So in lower than set point, the pump is should be run. Yes, but the color not change. Let me check the color again for HMI. Yes. Pump run. Yes, this one is mistake. So let's change to 1 and then download again. Because it will on, because it 1, condition 1 is turned on. Okay, let's set point again. 100. Let's see PLC also. 20 liters, 800 lira, 900 liter. Yes. So let's see, right now the pump is running. So if I adjust too high, it have delay time a little bit, and then will stop the pump automatically. Yes. If the level still low, the pump will start automatically. Okay. So this is just example about how to create the sample program for control the pump by using level radar and use the WinCC Flexible for create the HMI. Okay. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to read data from encoder by using PLC S7-200 CPU 224 HP. Okay. Before go to our software, I would like to explain a little bit for encoder connection and PLC connection. Okay. So here is the encoder, yes, and here is the connection encoder that we will connect from this connection to the input of PLC. Okay. So here is the voltage supply for plus, and it is the minus supply encoder, and it is the signal from encoder for A and B, yes, and we will connect to this one, yeah, this terminal. Actually we can connect from plus for positive from this supply, yes. If we supply 220 to PLC, we will got 24 from this terminal, yes, and this is a plus and this is a minus terminal. Okay. And for encoder A and B connection, we can connect to here, yes, I 0.0 and I 0.1. Okay. And if everyone would like to reset the counter, we can connect I 0.2, yeah, for connect. Okay. So it is the connection of encoder and PLC S7-200. Okay. So let's go to set up the parameter, or we can say wizard for high-speed counter to read data from encoder to the PLC. Okay, so let's go. So here I will use Step7 MicroWin version 4 SP9 and WinCC Flexible for create the new project for show the value of the encoder to HMI also. Okay. So first, let's open Step7 MicroWin and then go to communication to check communication between our PLC and CPU. Yes. Okay, I will connect the connection from PLC to my PC and then go to communication and then click refresh to check the communication between our PLC and PC. Okay, so right now it found one CPU 224 HP CN real 0202 and address number 2. Okay, and this is a baud rate 9.6 kilobyte per sec. Okay, so we can click OK. And the second step, let's go to tool, instruction wizard, yes, and go to HCS. Sorry, HSC, it means that high speed counter configuration, yes. And then click next. And here is the counter configuration, yes. Totally there are 6 high-speed counter that we can use, yes. And in this time I will use AC0, yes. And for mode there are 13, yes, modes of high-speed counter that we can use. Example, I will if I select mode 0, here is the description of mode 0. Single phase up down counter with internal direction control. No start input, no reset, right? If we use the mode 0, it will use only like this. So if we select mode 1, it's similar to mode 0, right? Mode 3 until mode 12, yes, like this. Power generation, yes. So we can choose the mode that we want and to match with our process that can use. Okay, so in this video I will use mode 4, yeah, single phase up down. It means that I can increase and decrease the value counter with the internal direction control. No start input, but use the reset also. Okay, so I will use I 0.2 for reset, yes. If we press the reset button, it will move the value to 0, right? Okay, so right now I will use mode 4, yes, have the reset button and go to next, yes, finish and go to yes, yeah. Okay, so here is the automatic generate for us, yeah, and here is the instruction, yeah. To enable this configuration within the program, use 0.1 or an edge trigger instruction to call this subroutine, yes, subroutine 1 from the main program block. Okay, configure AC0, yeah. So first we need to use the SM 0.1, yes. So SM 0.1 and then move the ACS in it to the main program, right? Because it is the subroutine, So if we would like to enable the subroutine, we need to move, okay, call it to the main program. Okay, so let's go to see the configuration. Config AC0 for mode 4, yes, CV, PV, up and down. Okay, enable interrupt start the counter. Okay, so I will use the SM0.0 SM0.0 for always on, right? It is the first scan. Yeah, if we would like to see the health, we can press F1 to see the health. Yes, and we can search SM. Yes, you see always on SM0.0. SM0.1 is on for first scan only. Yes, first scan cycle of PLC only, and it has many SM that we can use. Okay, so I will move double bird, right, for counter. So go to move and move double bird from AC0, right, because instruction here AC0 and mode number 4, right. So I will move the data to VD, example VD 200. Yes, like this. And let's check the program. Yeah, compile. Error 0. Yes, so we can download the program to the PLC. Yes, okay, and then we can online. Okay, so right now I already connected the cable from follow this connection. Yeah, follow this connection to the PLC already. So if I increase or decrease the encoder, yes, okay, right now I will increase the encoder. You see the value of encoder is changed. Yes, let me zoom. Okay, we can zoom. Actually we can zoom, right? Actually we can zoom, right? Okay, no problem. Okay, if I increase or decrease the encoder, yes, you see the value is changed. Yeah, increase and decrease, follow clockwise and anti-clockwise of encoder. Yes, direction. So if everyone would like to reset, we can write like this. Example M. So we can remark. We can comment like call subroutine. Okay, of high speed counter. Yes, and this is a read data from encoder. Yes, and the network tree we can write reset high speed counter, reset value of high speed counter. Okay, like this. And if everyone would like to reset, yes, we can write M0.0, and then I will let Q 0.0 is turned on, and then we will connect from this output to I 0.2, so it can reset. Okay, so I will download again. Okay, wait a moment for downloading. Yes, okay, finish. So we can increase and decrease the value of encoder, you see. And if we would like to reset, we just write this one to on. Actually, we can reset from the HMI, right? I will show how to reset from HMI. So here you see the input is turned on, and then the counter is reset to 0, right? Because I already connected the cable from Q 0.0 to I 0.2. Okay, I start increase and decrease again. Okay, so right now we will create the sample project of HMI for see the data of encoder in the HMI. Okay, so let's go to WinCC Flexible, and then I will use the empty project. Yes, and then go to the touchscreen type. Yes, right now I will use 170B 6 in color. Yes, yes, and then go to connection 1 example encoder HMI. Yes, and we will connect to S7-200, right? And I will use the PPI. Yes, and then use this port and baud rate. Yes, and this address of PLC. So first we can use the tag. Yes, create the tag. Example encoder value. Yes, double word, right? So VD 200, right? Let's check again to confirm. Okay, VD 200. Yes, and one more for reset, right? Reset counter. Okay, or reset encoder. Okay, boolean, right? So boolean M 0.0, right? Okay, read data from encoder, and this command reset encoder, right? Okay, so let's go to screen, and then we can write text. Yes, so read data from encoder using S7-200. Okay, increase a little bit for text. Okay, and then go to center, and then go to middle. Yes, like this. And I will use the color, right? Sample okay, blue. And I will use the IO file, yes, for read the data. So it is the output, right? And example like this. Yes, so many. And then I will use the counter, yes, this one, decimal, and I will adjust the font, yes, the text format should be center and middle, and then example 16, yes. I will change color to be red, and text color should be green. Okay. Okay, like this. And I will create one more button for reset, right? So reset encoder, yes. Reset data of encoder, yes. Okay, when I press and release, it will reset the encoder, right? So this one I can copy data from encoder, yes. Actually, if we got the data from encoder, we can take this data to use the program to control the process, right? Okay, so I need to configure the button, right, for reset the encoder. Okay, let's go to the event, right? Go to the release, and then go to please set bit, right? Okay, set bit, reset encoder, and if I release, it will reset, right? Reset encoder also, yes. So please set and release, reset. Okay. Okay, I will change the color to be like this. Okay. And font maybe 12 something, yes. Okay. So we can download, yes, to the HMI. Okay. So right now downloading the project of WinCC to the HMI. Yes. Okay, done. So we can online to check, yes. Okay, so right now you see the value of counter is set to 6, right? So if I increase the encoder, yes, I will increase the encoder and decrease, yes. Increase the encoder, you see the value of encoder is vary, yes. Decrease and increase, yes. And if I would like to reset the value, I can press this button, yes. You see when I press the Q0.0 is turned on, and then the I 0.2 is turned on, and then reset the counter. Okay. And if I increase and decrease again, I will got the value again. Okay. So if I would like to reset, I can please reset. So we can reset the counter. Okay. So this is the instruction how to create the sample read data from encoder by using PLC S7-200 CPU 224 HP. Okay, and I hope everyone will understand about this video. And if have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. For in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to create PID control on PLC S7-200 CPU 224 HP. Okay, and here is the PLC S7-200 CPU 224 HP CN, and I will connect the analog input for the extension. Yes, for extension we already learned in the previous video for analog input. Okay, so it will start from analog input address AIW4 and go to analog output for AQW0. Yes, right now I will use the 0 to 20 milliamp because if we have the input 0 to 10 volt, we can also use this terminal, but in this time I will use the current 0 to 20 milliamp. Yes, and I will use the software Simatic Step7 MicroWin version 4 service page 9 to create the sample PID control. Okay, so let's go to our software. First open Step7 MicroWin. Yes, and then go to tool and then choose the wizard. Yes, instruction wizard, and then go to the PID. Yes, because we need PID control, so we need to choose PID, and then click next. And here we can use for save 8 loop for PID control. Yes, but in this video I will use PID number 0. Yes, and then click next. And here is the specify the rank. Yeah, example low rank 0 and the high rank is 100%. And this is a loop parameter gain, integrate time, derivative time. Yes, it is the minutes. Yes, and the sample time second. Yes, 1 second. default. So this we can adjust later when we tune the PID. So let's choose the default first and then click next. And here is the analog PID or digital PID, so we can choose. But for this time I will use the analog PID first. Yes. And here is the PV process variable 0 to 32,000, yeah, for analog input. And loop set point 0 to 100%. And here is the high rank and low rank of analog, yes, 0 to 32,000 also. Okay, so let's choose default first. And here is the alarm, PV alarm, low alarm and high alarm. Yes, we can tick like this and we can set the alarm setting. Okay, so in this time I don't set the alarm, so click next to continue. So here is the address, start from VB0 until VB119, yes, for address. So click next. And then if we would like to add the manual control of PID, we can tick like this, yeah. And then click next and click finish. It will generate, automatic generate, yes. And we must call the subroutine of the PID control to the main program, right? So I will use the SM0.0, yeah, for always on. And then I will call this block to the main, yes. So here is the PV process variable of the PID. Example, start from AIW4, yes, AIW4, W4, yes. And here is the set point for real data type. I can provide the address, yeah, example VD 300, yes. And here is the auto or manual command, yes. So I will choose the M20.0 example for select the manual and auto, and move to M20.1, and I will choose this one for auto mode. This is a manual command, real data type also, so I can use VD 400 example. And here is the output for control the drive or some electrical devices. So analog output start from AQW0, yes, AQW0, okay. So that's all for set up the parameter, yes. So compile, yes, no error occur. Then I will download to the PLC, yes. Stop the CPU. Yes, start the CPU. and we can online. You see right now is the auto mode. When we would like to use the manual mode, we can on this one, it come manual mode. Okay, so I write on first, yeah, auto mode, yes. Right now the milliamp is show 0, yes, of analog output. And I will go to PID tune control panel, yes. Okay, so here is the PID tuning control panel. You see we have a PV, yes, process variable, and have the set point, yeah, and this is the scale 0 to 32,000 for output for control the VSD or electrical devices. We are analog output. Okay, so I will show the analog output right now. Show 0 milliamp. Yeah, you see right now the analog output is show 0 milliamp. Yes. Now I will start the set point. Yes. Actually, we can set from the HMI or some keypad. Yes. To set point 0 to 100% that we want. Yes. So here we can write. Yes. Example write 50%. Yes. You see the set point is 50%, and the output start vary the value. Yes, right now around 10 milliamp. Yes, right now around 10 milliamp. So if I adjust the PV, yes, adjust the PV, you see the output is start decrease because the PV is bigger than set point. Yes, and if I adjust the PV is lower than set point, you see the milliamp of analog output start increase. Yes, until nearly 100%. Yeah, 20 milliamp is 100%. You see the graph. So it will automatic calculation between the PID tuning. Okay. Actually, we can use the manual for tuning also. Example, adjust the integrate time. Yes. Adjust the gain. Adjust the derivative time. Yes. To make our process is smoothly. Yes. So we can tune in this. So this is the instruction how to create the sample PID for control the process. We are using the PLC S7-200 CPU 224 HP. Okay. I hope everyone will understand about this video by follow me. Yes, about how to create it. And the next video I will use this one link to HMI. For control example set point, we can set 50% or 25% or 100%, so we can set point and monitor the PV, yes, and output on the HMI also. Okay, so in this time I would like to say thank you very much for watching my video, and I would like to request all of you to like, share and subscribe my video also to get more notification and more video that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will go to part 2 about how to create PID control on PLC S7-200 CPU 224 HP, part number 2. In the previous video, we already learned about how to create the PID block and tuning the PID control, yes, with PLC S7-200 CPU 224 HP by using Step7 MicroWin version 4 page 9. And for today we will create the touchscreen, yes, HMI, like set point, feedback, output and manual set point, and button auto and manual mode for control from the HMI. Okay, and I also using the Step7 MicroWin version 4 page 9 and WinCC Flexible 2008 page 3 for connect to the HMI. Okay, so let's go to our software to create the new program of WinCC Flexible for create the HMI. So let's go. So I will use the existing project of PLC S7-200, yes, for PID control, yes, like this. And actually we can modify the parameter of this one before we create the HMI, right? So example, I can comment, yes, PID block control, yes, and I will modify some parameter, yes, some address for connect to the HMI. Okay, so here I can use the NO for button, right? Like this, and it is the mode, yes, mode control M20.1 on. It means that auto control, yes, and when it off, it manual control. Okay, and for manual control and auto control, I will move yes, the output, yes, directly to output from the HMI, right? So I will insert the move, yes, move word, okay, move word. First is the analog input, right? So I can move to VW 700. Yes, example like this. This is for PV, right? Feedback from the instrument. And I will move word more. Okay. If the auto mode, right? So this one should be on, right? So I will insert M20.1. Yes. When this one turn on, it means that auto mode, yeah, auto control. So I will move, yes, some word, yes, example VW 800, yes, to the analog output, yes. And if this one is turned off, yes, M20.1 is turned off, then I will move the value from the touchscreen, yes, for manual mode, example VW 900, to the analog input, analog output also, okay. And it will show the value on the HMI also, right, for output. So I will move, yes, to VW, example VW 1000, yes, and also move, yeah, this one to HMI also, right? So we should show the HMI with the address VW 1000 value, right? Okay, so that's all. Let's compile, yes. So no error occur, right? Okay, error 0. So we can create the HMI, yes, for test. So first we need to create the manual set point, yes, set point value and manual set point value, right? Okay, so let's go to HMI. Let open WinCC Flexible, yes, and then create the empty project. And for this one I will use the panel, yes, my panel, my touch panel, yes, TP170B 6-inch color, okay. So first we need to create the connection, right? Okay, so double click on the connection and example HMI 1 connect to PLC 200, right? S7-200. From HMI, yes. And we will use the PPI, yeah, connection, and then choose the baud rate, yes. Normally I choose 9600 for baud rate, yes, and use the port IF1B, yes, and here is the address of the PLC S7-200 CPU 224 HP, yes. Okay, so let's go to create the text. So first is the set point, right? So SP is the real, right? Let's see here is the real VD 300. So real VD 300, yes. Set point value from HMI, yes. And the next is the PB, right? PB, so VW 700, yes. So PB process variable, it is the word, right? So word VW 700, okay. PB process variable, yes. And one more for output, right? And manual set point, right? So manual set point VW 900. So manual set, okay, VW 900. So manual set point from HMI, yes. Manual set point from HMI. And one more for output, right? This one VW 1000. So output, it means that analog output. So VW 100, sorry, 1000 output to VSD, example output to VSD. And this one process variable from instrument, okay. And one more for selection, right? So M20.0, yes, for command select auto and manual. So mode, yeah, mode control, mode CTL, it means that mode control. It is the boolean, right? So boolean M20.0, yes. Mode control, right? Okay. So we can continue to create the screen, yes. So first I will create the title, yes. PID Control for PLC S7-200 CPU 224 HP, okay. And I will increase the font a little bit, yeah. Go to property, go to text, and then I will adjust to center, middle, and 12, example 12, and bold also, right? Okay, like this. Maybe adjust to 10, yes, or 11. Of PLC S7-200 CPU, yes. Okay, And let's go to the color. For change the color, example color red, like this. Okay, and then go to the text. Yeah, I can copy from here. So first set point, right? I will change color to blue. Yes. First set point, so I need to create the IO file, right? For set point, like this. And go to property and then go to the background. I will change to black. And the text color, I will change to green. And I will increase the font, yes, to 14, yes. Okay, like this. Okay, so we need to copy this one to another variable, right? So set point PB output and manual set point, right? Okay, totally 4. Okay, like this. Okay, like this. And the first one is set point. Yeah, I will align to be like this. Yes. So first set point. So let's go to input, right? For set point. Yes, set point. Like yes, format like this. Yes. And it should be property text. Should be middle. Yes, center and middle, right? Okay. And the second one is the PB, right? So PB, or we can say feedback. Okay, feedback. So feedback is the output, right? Okay. Input from instrument. So PB, yes. And like this also. So PB we need to scale, right? From 32,000 to 100, right? Okay, so let's go to here and then click here. Go to property. Go to linear scaling. And if PLC if HMI 100%, the PLC should be 32,000, right? Okay. And one more for output, right? So output or manual set point, right? Manual SP, yes. Manual set point. So it is the input, right? Manual set point. Yeah, it is the input. And we need to convert also, right? So what text that we need to use? So manual set point. Okay, this one we need to scale also, right? So go to linear scaling and then enable. And if the HMI 100%, the PLC should be 32,000, right? Okay. because we move this one to the analog output directly. Okay, so the last one for the output, right? So output, okay, we need to convert also, and it is the output, right? So output and go to the rank, yeah, convert also, linear scaling, and then go to enable the PLC to 32,000, yes, 32,000, and the format should be like this. Okay, and actually this one is the unit, right? Example bar, yes. PB is the unit also, yes. And the output and manual set point should be percent, right? 0 to 100%, yes. Should be like this. Okay, should be like this. And one more for button, right? Button mode control. Okay, for the button mode control, we can use the button, yes. Okay, so example, this is a auto, yes, auto mode. Okay, auto mode, and I will copy one more for manual mode. Okay, manual mode. Okay, good, like this. Okay, so when press auto mode, right, the person M20.0 will turn on, right? Okay, so go to the release, yeah, it will set, right, set the bit mode, right, set the bit mode control, yes. And when the active, it should be change the color to, yes, animation mode control, yes, it will change to, yeah, it will change to green, right? Okay, and one more for manual mode also, yes, go to event and then go to release and then reset the bit, right? So reset the bit mode control, and then we'll change the color also, yeah, go to animation and this one mode control, 0 it will green, and 1 it will red, right? It will no color, right? Okay, so good, let's test. Save the project, yes, I will save to desktop and then go to create the new folder, PID HMI, yes, PID HMI. Okay, actually we can simulate to check the screen before go to download to the HMI, right? You see here is the so big, so it will hide, so I will increase to, sorry, decrease to 10, yes. But not so big, right? Okay, like this. Okay, save again and then simulation again, yeah, to check. Make sure it show like this before we download to the HMI. Yes, and I will adjust this one to be like center. Yes, like the center. This one also. Yes. Okay. And let download to the HMI. Yes. So to download to the HMI, I will use the connection. Yes. Convert from COM port to RS232. Yes. So let's connect it. Okay. So first let's go to check the COM port. Okay. Right now I use COM7 for connect from my PC to the HMI for downloading. Yes. So to download to the HMI, let's go to here and then click download. Yes. And I will use the COM7, right? And this default baud rate, so we can click transfer. Yes. And we can confirm yes to download the project to the HMI, right? So if I confirm yes, yeah, you see the HMI is right now downloading. Yes, transferring. Yes. And then reboot, automatically reboot. Yes. And we can go to the PLC project and then download to the PLC. Yes. Okay, download. And start the project. Yes. Start the PLC and then we can online to check. Yes. So you see right now is mode automatic mode. Yes, because M20.1 is turned on. You see auto mode. Yes. And the set point is right now 0. Yes. So if I adjust the set point to example 50%. Yes. Yeah, 50% or 50 bar. Yes. You see here is 50. And the PV right now show 66 bar. Yes. 66 bar. And we can go to the PID control panel. Yeah. For see the train. Yes. PID control panel. And then here you see. Yes. Okay. Right now set point 50 bars. And the output is around 48%. Yes, 48%. So if I adjust the PV, yes. Adjust the PV to less than the set point. Okay. Less than the set point. You see the output is start increase, a little bit increase step by step, right? So let's see the setup of the PLC and HMI. Okay, right now you see the PV and SV is nearly the same, and the output is 67%, yes. So if I adjust the PV to be bigger than SV, yes, feedback, you see the output is decrease, okay, start decrease. So if I adjust the set point to 90%, sorry, 90 bar, yes, example, you see the output is start increase because the feedback is less than set point, right? Okay, if I adjust the PV, yes, you see the milliamp is vary also, yes. Example 90%, okay, nearly 90%. Yes. You see, it vary about, yes. So if I would like to use the manual mode, I press manual mode, yeah, and I can set point, yes. Example 100%, yes. 100%. $900 VW 900. Okay, let me check. Okay, let's see the point of manual set point. Yes, I'm not yet insert it, so sorry, and correct this one. Yes, so manual set, yeah, and go to the property again. Okay, that's correct, and save the project again, and then download to the HMI again. Sorry for my mistake. Okay, forgot insert the take to the HMI. Yes, so it not work if we press the manual mode. Yes, so let's check again. Okay, okay, let's test again. So if I select to the auto mode and manual mode again, and I would like to the manual control, I can press the set point. Yeah, example 90%. Yes, you see the milliamp is varied to 18 milliamp. And if I would like to set the 50%, yes, you see, we connect directly to the analog output. Yes, okay. Example 100%. Yes, you see 20 milliamp. Yes, it error a little bit for milliamp. Yes. So this is a concept how to create PID control with PLC S7-200. Yes, CPU 224 HP, and I hope everyone will understand about this step and can do by yourself. Yes, and if everyone would like to tune the PID, let's go to here and then press F1, yeah, to help, because here is the PID help how to tune. Yeah, example I put the value of gain, integrate time, and deviation time. Yeah, we can follow this one. Example 0.57. Yes, 0.57, 0.16, right? 0.16, and we can update PLC like this and then click yes. And if I adjust the PV, yes, adjust the PV, we will see the output. Yes, the output will come the same this graph. Yes, you see this graph is smoothly when we tune like this. Yes, it will up step by step until the same as the PV. Yes, so thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new videos that I will create step by step. And I'm also sorry if I have mistake, because my English is not so good, so I'm so sorry. And for this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the PLC S7-200 CPU 226CN and EM231CN, 235CN connect with the PT100. It means that the temperature sensor, and connect to the control valve by using the analog output. Okay, so before go to create the program, I would like to explain a little bit about the wiring diagram of this module. Okay, so first here is the supply 220 volt AC connected to the circuit breaker and supplied to the PLC. Okay, and if we provide 220 volt AC, we will got 24 voltage from this terminal. Yes, that mark like this. It has ML plus and ground. Yes, so we can take the 24 voltage from this terminal to connect another expansion module like this. Okay, and here is the analog input module that we can call EM231CN, and here is the analog input channel number 1. Totally, if we choose EM231CN, we will got 4 channels of analog input. Channel number 1, we will use 3 terminals. Channel number 2, 3 terminal more, and channel number 3, 3 terminal more, and the last one is channel number 4. We will use 3 terminal more. Okay, and here is the analog input and analog output the same. It means that this module we can use 4 channel of analog input and 1 channel for analog output. Okay, so actually we can also don't use this one. We just use EM235, and then we can connect the analog output and input the same card. Okay, but in this section I just show and share about how to connect this module. Okay, and here is the PT100 that I will use 3 wires for connect to the temperature transmitter, and then it will generate the current milliamp for 2 milliamp from this terminal to connect with the PLC. Okay, and for this one we can set point to control the control valve by using the 4 to 20 milliamp or 0 to 20 milliamp to here, and then it will generate to this one also. Okay, so in this section I just show how to create the program for testing, and then in the next topics I will show and share about how to create the control. Yes, it means that we can set the PID control from the temperature to open the valve or something that we can do also. Okay, and in this section I will use software Simatic WinCC Step7 MicroWin version 4 SP9 by using the PPI cable connect from my PC to the PLC. Okay, so this is the concept of this section, and before create the program, make sure that we can wiring of this module, otherwise we cannot test this module. Okay, and I will explain more about the deep switch of this module also in the next step. Okay, so first let's go to our software Step7 MicroWin version 4 page 9 to create the scaling or some program block to control this module. Okay, so let's go. Okay, before go to create the program block, yes, by using this software, I would like to show and explain a little bit about the deep switch of the analog input and output module. Yes. So first go to the analog input module. Yes. EM231 analog input module, and here is the wiring diagram. Yes, that I already explained. And here is the analog input module and output module. Yes, diagram. And the next step, we will go to the setting deep switch. Yes, so here is the setting configuration switch of the module EM231. Yes, so we can use 0 to 10 volt, 0 to 5 volt, or 0 to 20 milliamp. Yes, by follow the deep switch. Yeah. So first, if we would like to use the 0 to 10 volt DC, we can choose on for deep switch number 1, choose off for deep switch number 2, and choose on for deep switch number 3. Okay. And one more configuration, if we would like to use 0 to 5 volt or 0 to 20 milliamp, we can also deep switch number 1 is on, number 2 is on, and number 3 is off. Okay, and this is an unpolar, and this is a bipolar section. Okay, so normally I use this setting. Yes. And the next step, here is the deep switch configuration for EM235 module. So right now I will use 0 to 20 milliamp. Yes. So I will choose the deep switch number 1 is on, deep switch number 2 is off, deep switch number 3 to number 5 is off also, and then deep switch number 6 is on. Okay. So it's very important for deep switch configuration. Yes, otherwise we cannot test this module, because if we wrong selection, we will cannot see the raw value of this module. Okay, so it's very important for this deep switch, right? So the next step, let's go to the program. Okay, so first we need to create the scale. Yeah, here, because our PLC is 0 to 20 milliamp, right? And our transmitter output of transmitter is 4 to 20 milliamp, but the scale of the PLC is 0 to 20 milliamp. So we should convert by using the scaling. Yes. So first we need to create the scaling, and second we need to create the analog scaling, and the third we will create the analog output scaling. Okay, totally 3 blocks that we will create. Yes, so let's go. Okay, first open software Step7 MicroWin version 4 CV page 9. Yes, And then first go to communication, check between our PC and PLC. So right now I already connected the PPI cable from my PC to the PLC CPU, and then we can click here, double click to refresh. Okay, and then right now it detects one CPU 226CN. Yes, and then we click OK. So to create the scale, first we need to insert the subroutine. Yes, here. So I will insert the subroutine because totally we have 3 subroutine, right? Analog input scaling, and analog output scaling. Okay. So the first one is scale, and the second one of subroutine is analog input scale, and the third one is the analog output scale. Okay, so we need to create the scale first. Okay, I will zoom a little bit. Yes, zoom in a little bit, maybe 8. Yes, so go to scale of subroutine, and then for parameter of subroutine, we need to use this one that I already summarized in the Excel file. Yes, so we need to use this formula: output equal input minus low scale in multiplied by high scale out minus low scale out divided by high scale in minus low scale in and plus low scale out. Okay, and here is the data that I already created, and we can simulation. Example, my input here, and the high scale input around 22,000 for S7-200, and this one from 0, and high scale out that we will got around something, example around 100 something. So if we write the input, example 0, it will be 0 also. Yeah, if we write 1600, yes, we will got 50 because the rank is 0 to 100. Yes, so it is the 32,000 divided by 2, so we will got 50. Okay, so we will use this one. So we need to create the 6 parameter, right, in the block. The first one is input, second is high scale input, low scale input, high scale output, low scale output, and the output is the result. Okay, so let's go. So here is the row of input. So actually we can write input, and the data type is real. Yes, so we can comment anything. Example input raw data. Yes, and the second one is high scale input, right? So high scale in, it is the real also, so we can comment high scale input. And the third one is low scale input, the data is real also, and then we can comment low scale input, and the fourth is high scale out. Data type real also, so high scale output, and this one low scale output, data type real also, and we can comment low scale output, and the last one for output, right? So this is the output, so we can write output, and it is the real also, and we can comment output value. Okay, so let's go to see the formula. Yeah, here is the formula. So the first one, we need to calculate between input and low scale input, right? So actually we can copy this comment to here, easy to understand. Yes, so this one is input minus low scale, right? Input minus low scale input. Yes, so low scale in. Yes, so the first one, we need to create the always on contact, so SM0.0, otherwise it will error, and then we will use the subtract, right, between input and low scale in. Okay, so go here and then sub real. Yes, here. So we will take input. Yes, we can type input minus low scale input, right? So L scale in. Okay, and then the output is we will insert the temporary value. Yes, for this variables. Example temp1. So it is the real also, right, for data type. So here I can choose temp1. Yes, it is the local variable. Yes, and the second block, we need to create the subtract also, right, between high scale out minus low scale out. Okay, so we can go here and subtract. Yes, so this one between high scale out, so high scale out minus low scale out, right? So low scale out, and then we will insert one more variable. Yes, example temp2, and it is the real also for data type. So here we can use temp2. Okay, and then we will continue to use, right, the multiply, right? So we can use multiply real. Yes, okay, like this, and then we can multiply by this one. Yes, and this one, and we need to create one more temp, example temp 3. Data type is real also. So here we can type temp 3. Okay. And then we will continue to use the subtract, yes, between high scale input minus low scale input, yes. So go to sub real, yes. Actually we can copy and paste from this one also, but here I just explain, yes, about how to write the block. Okay, so subtract between high scale input minus low scale input, right? So high scale in minus low scale in, and then create one more for temporary variable, yeah, temp4, and it is the real also for data type. So we can type temp4 here, yes, and then we will divide this one and this one, right? So we can divide real, right? DIY, sorry, div real, and divide this one and this one, and then we will got temp5, yes, it is the real for data type, and this one for temp5. Okay, and the last formula is plus by low scale output, right? So we can go to add, right? Plus add real, and then add this one with the low scale output, right? Here, low scale output. Okay, low scale out, and then we will generate to the output, right? So here we can use this one, output. Okay, so that's all for create the block of scale, yes. Scale, this scale is used for input and output, yes. So if we would like to use this one, we can drag and drop from here, yes, to use. Example here, yes, we will got like this. But right now I will go to create the analog input scaling first, yes, here. So here we can keep first, yes, and then we can save the project, otherwise it will lose something if any error. So example PT100 S7-200, okay, and if we compile we will got like this, okay, no error occur. So the next step we will create the analog input, yes. For analog input, let's go to Excel file here. So this is a formula of analog input module, yes. So the formula is output equal input multiplied by high scale minus low scale divided by maximum of raw data and plus by low scale, okay. And here is the data that I already simulate, yes. Example, we set 0 to 100 of example 100% or 150 degrees Celsius something. So if we put the raw data, example raw data around 32,000. Yes, 32,000. Okay, I will change this one because it is the formula for another PLC. So formula is 32,000. Yes, so we will got 100% for output. Yes, okay. And if it divide by 2, example 32,000 divide by 2, yes, we will got 50% or 50 degrees Celsius something. So we will create the formula by using this. Okay, so I will copy this one and paste here. Easy to understand and create step by step. Yes. So the first we need to convert. Yes. But before convert, we need to create the parameters. So totally we must create the 4 parameter here. So input, the first one is in, and the data type is integer, right, from the analog input. Yes, so this is the raw data. Yes, raw data input, right? Okay, and the second we need to create the high scale. Yes, high scale, it is the real, so high scale. And the third one is the low scale, so low scale, it is the real also. We can comment low scale. Yes, and the last one is the output, right? So output we can put here, out, it is the real also, right? Output for you. Okay, and for this row we need to create the temp. Yes, so first we need to insert the always on contact, so SM 0.0, and the second one we need to use the subtract, right, between high scale and low scale. So we can use sub real. Yes, so this one high scale minus low scale. Yes, and then we will create the temp variable, example var1. So this one should be real. Yes, for data type. So here I can use var1. Okay. And then we will multiply by input, right? But the input is the integer, right, from the analog input. Example AIW0, AIW2, AIW4 something. So we need to convert from integer to real, right, before calculate this one. So we can copy this one to here, and here we can convert by using the integer to double integer, right? Because we cannot convert directly from integer to real, so we must convert from integer to double integer first. So this one is in, so we can use in, and then I will connect this one. Yes, and then I will create the var2, and the data type is double integer, right? Because we convert from integer to double integer, so this one should be dint, or we can choose like this example. Yes, you can click the drop down and then choose this one. So var2, okay, and then I will convert from double integer to real, right? So di to real, yeah, this one, and then copy and paste this one to here, and I will got one more for var3, and the data type is real, right? Because we convert from double integer to real. So here is var3, yes. And then right now we already convert from input integer to real. Then we can use this formula. Okay. So the next step we will multiply by this one and this one. So we can use multiply real. So real. Yes. Mul between this one and this one. Yes. And then I will got var4, and the data type is real. So this one should be var4. Yes. And I will divide this one by 32,000. So 32,000. So I can use divide real. Actually, this one we can change followed by our PLC scaling. Example 4 to 20 milliamp, or 0 to 20 milliamp, or 0 to 5 volt. So we can create this scale. Okay, so I can copy this one to here and create one more for temp. So var5, it is the real also. Yes, and here I can use var5, and the last step is plus by low scale, right? So here I can use add real, and this one plus by low scale. Yes, so low scale. Okay, and this one for the output, right? It is the result here, so we can write out. Yes, this one. So we can compile. Okay, no error occur. Yes. So right now we already created one more block for analog input scaling. Yes. So we can drag and drop to use if we want, like this. Okay. And the next step we will create the analog output scaling, right? Okay, let's go to Excel file for analog output scaling. So here is the formula for analog scaling, and I already created the formula. So the formula is output equal the maximum of raw value. Yes. Multiply by input minus low scale, and divide by high scale minus low scale. Okay. So we can copy this formula to our program. Yes. So we have 1, 2, 3, and 4 parameter, right, that we need to create here. So the first one is input, and the data type is real. Yes. The purpose is we need convert from real to integer, because when we set point example 100.5% or 95.5% something, it is the real, and it will generate automatically to a milliamp or volt of analog output, right? So we need to convert from real to integer by follow this formula. Yes. So input is the real, so input value, and the second is high scale. It is the real also. So high scale. Okay. And the third is low scale. It is the real also. So low scale. Okay. And the last one is the output, right? So output, it is the integer, right? So output. So first we need to convert from input minus low scale and then divide. Yes. So we can use subtract. Okay, so sub real between input and low scale, right? So low scale. Okay, and then I will create the temp. Example value 1. It is the real for data. So here I can write value 1. And then we will use the multiply, right? So multiply real. Yes. Multiply by this one and maximum, yes, of raw value. So example 32,000. Yes. And then I will create value 2 for temp 2, and it is the real also. So value 2, yes. And then we will divide this one by high scale minus low scale, right? So we can copy this one to use. Yes. And don't forget use the SM0.0 for always on. Yes. So we can use the high scale minus low scale. So high scale minus low scale. Sorry, this one high scale, 8 scale. Okay. 8 scale. Yes, minus low scale. And then I will create one more for value 3 for temp 3. It is the real also. So value 3. And then we need to use the divide, right, between this one and this one, right? So we can use divide real, and then I can copy this one to here and this one to here, and then I will got the temp 4, right? So value 4. This variable, everyone can create some variable that we want. Yes. So value 4. Okay. and this is a real, yes, real value, so we need to convert to the integer, right? Okay, so I will use the function truncate, yeah, this one. The first we need to convert from real to the double integer, right? You can see the help by pressing the F1, yes. This is a convert from real to double integer, yes. Here it is their function, yes, so we can read. And then I will use one more for double integer value, example value 5, and it is the double integer because we will convert from real to double integer and then double integer to integer, right? So this is the value 5, okay, and then I will convert from this value to integer, right? So we can convert from the I double integer to integer because our analog output is integer, right? So I can copy this one, yes, and here is the output, right? So we can use output, okay, and we can compile and save the project, okay. So no error occur also. So right now we already created scale in out, scale analog input, and scale output. So in the next step we will drag and drop this block to use, yes. So first we need convert from the analog input to the raw value, right? So the first one we need to create the SM0.0 for always on, and then I will use the scale, drag and drop from here to here, yes. And I already tested with my PLC. For the input I can use the AIW 0, yes. Sorry, it is the real. So I will convert from the integer to real first, yes. So I will copy this one to here, and then I will convert the analog input to the real first. So here we can use the, so here we will convert from the analog input to the real value first, okay. So I can use the DI, sorry, I to DI, convert from AIW 0 to the example this one var1, it is the double integer dint, yes. So this is a var1, and the next step I will convert from double integer to real. So we can use di to real, because this scale is real, yes, for data type. Otherwise we cannot use the integer to here. So I will convert this one to real. Example Y2, it is the real. So this one is Y2 VA2, and then I can use this one to here, yes, and then it not error occur. Okay. So for this PLC I already tested for high scale. It's around 32 something. So we can use this scale first, because I already tested for my PLC 6382.0. Yeah, it means that 4 milliamp, because our transmitter is 4 milliamp. So 4 milliamp around 6382 something, yes, and we will got output that we need 2000 32,000, yes, sorry, and start from 0 to 0, okay, for low scale. And then I will use the another memory, example MD0, yes, and then we will use the one more block for show the actual temperature, right? So I will use analog input block, yes, from here. But here is the input for integer, right? So we need convert from this real to integer first, yes. So I can copy, cut this one, and then we can convert this one by using the function trunc, yes, convert this one to the, it means that convert from real to double integer, and then convert from double integer, yes, to double integer, right? So I can choose the VA3 double integer, DINT, yes. So VA3, and then actually here we can use another memory that we want. Example AC0, yes, and then we can move, yes, and then we can move, yes, use move word, okay, we can move word from here. Example VW0, yes, so we can move word from this one to the scale, yes, here, yes, and then this temperature transmitter I already set the scale, yes, so 0 to 100 degrees Celsius, and this is a memory, another memory, example MD4, yes, for real, MD4, okay. So if we download, we can got the actual value of temperature here. So I will save the project and then go to download. Okay, stop the CPU. Run the CPU and then we can online by pressing here. Okay, so right now the actual temperature around 24 something here, because the raw data around 12,000 something. Yes, and I will show the actual temperature. It different around 1 degree Celsius. Yes. Okay, let's see. Here is the temperature around 25 degrees Celsius, and our PLC show around 24 something, so it error a little bit around 1 degree Celsius. Okay, and here is the connection that I already connected the milliamp to here. Yes, to this terminal. And the next step, we will write the program for control the control valve. Yes. So the actual temperature around 25, and here show around 24. It error accuracy around 1 degree Celsius. So no problem. So if we would like to adjust something to be the same, we can adjust here. Yes. So the scaling is very important, that we can scale from another value to convert to another value. Okay. So the next step, we will use the unlock out for test the actuator, right? To test this one. Yes. So I can offline, and then we can command analog output module to control the control valve. Okay, and here we can command actual temperature. Yes. So it's very easy if we created the scale of analog output. So we just drag and drop here, and then don't forget use the always on. So SM0.0, and here is the memory, another memory that we want to write the output. Example MDH or MD10. Yes. And example scaling from the 0.0 to sorry, the high scale should be 100.0, because the control one actually we can use 0 to 100%. Yes, so we can set scale 0 to 100, and here is the address of analog output, right? So AQW 0, right, like this. So we can save the project and then download to the PLC, and I will show and share about how to test. Okay, start the CPU. Okay, so right now it show around 0. Oh, MD10 is already used, right? So I will use another MD. Example MD12. Because MD10 maybe we already use, so complete with another address. So we need to use another memory. Okay, MD12 is 0 right now, and the milliamp is show 0 also. Let me show. So here is the analog output terminal that I connect to the multimeter. Yes, because it just example. Example, this is a control valve. So we can set point from the touch screen or something here that I will show in the next video. So here we can write example 10%. Yes, let's see the milliamp is up to 10%. Yes, example 50%. Yes, 100%. Okay, 20 milliamp, right? So we can use this step to control the control valve. Yes, by set from the touch screen or something. Okay, but I will show in this step in the next video. Yes, about how to create the scale or create the touch screen by using the WinCC Flexible. Okay, so we need the feedback from the actuator to another channel of the analog input, right? So we must create the scaling also. So we should follow this one for feedback. So first we need convert from double integer to integer, right? Sorry, from integer to double integer, and from double integer to real, right? So we can comment feedback from control valve. Okay, so 4 to 20 milliamp, right? This one 0 to 20 milliamp. So here, if we would like to convert something, example 4 to 20 milliamp, we can follow this step. Yes. So here I can copy, convert from integer to double integer, from double integer to real. So this one AIW6, because I use the last channel. So AIW0, AIW4, sorry, AIW0, AIW2, AIW4, and AIW6. So this one AIW6. And then this one I can create the VAR4, VA4, and this double integer, right? DINT. So VAR4, VA4, yes, and convert this one to real. So VA5, it is the real. Yes, so VA5, and then I will do the scale, right? So scale, and don't forget use the always on. Yes, and then we can copy from this one to here. Yes, and then example MD12, this one I use 12 already, so MD 26, yes, sorry, 16, and then I will convert. Yes, so I can copy this one to here. Yes, then I will use this memory to here. Example AC10, AC4, but actually we can use another address or another temp. Yes, so in here I will be a 6 and use the temp, and this is a double integer, right? So DINT, so VA6, and this one convert from VA6 to double integer, right? Cannot use, right? AC2, we can test with AC2. Example VW4, yes, and then choose the AIN, right? And then we can use the VW4, yes, and example MD 20, yes. So let's test together. Okay, let's online to see the status. So right now it show around 100%, because right now I select the milliamp to 20 milliamp. So if I adjust, yes, let me adjust. If I adjust the milliamp, yes, let's see here. Okay, around 0%, yes, it is the feedback. This is around 25%, 50%, 25%, and 100%. Okay, so the raw value will change, yes, if we select. Okay, so that's correct for our scaling. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to say sorry if I have a mistake in this video also. And in the next video, I would like to show and share about how to bring this signal to show on the HMI, yes, by using this block. Okay, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our simulation and testing with Simatic MicroWin version 4 SP9 and WinCC Smart version 3 that connect with PLC S7-200 wiring with the PT100 and control valve. Okay, and this is the part 2. In the part 1 we already learned about how to wiring and create the scaling for analog input and output that already connected and simulation between our PT100 and control valve. Okay, so in this part 2 I will show to everyone about how to edit the schematic WinCC Flexible Smart version 3 connect to the HMI that will show the actual value of temperature and the set point to the control valve. Okay, so for wiring the connection we already learned in the previous video, so in this video I'm no need to show again. Yes, so let's go to our existing project of Simatic MicroWin and create the new project for WinCC Flexible Smart to download to the HMI. Okay, so let's go. So first I will open the existing project that we already learned in the previous video. Yes, so open, and here is the existing block that we already tested in the previous video. So let me compile and then download to the PLC again. Yeah, so first check the communication between our PC to the PLC. Okay, right now it found one CPU 226. Yes, address 2, and this is a baud rate for communication, and then press OK, and then go to the button download. Yes, or we can go here and then click compile. Yes, to check our project has error or not. Yes, and then go to button download. Yes, okay, and then click download to stop the CPU and then download our program to the PLC. Yes, stop. Okay, and then run the CPU again, and we can online to check for monitor. Yes, so right now the temperature show around 22 or 23 degrees Celsius, and for the set point to control valve it is 0. It means that 0 milliamp or 4 milliamp. And for the feedback right now 49% because I already select the standard source to 12 milliamp. Yes, so the concept is we need to show the actual temperature, and we can set point the control valve by manually, and also show the PV. It means that process variable of the damper. Yes, of the control valve. So to create the screen, let's go to the software WinCC Smart version 3. Yes. Okay, right now I will use this software to create the screen for HMI. Yes. So first open the software. Yes. And then create a new project. This is a Chinese version. Yes, because this HMI is only support for Chinese version. Yes. So first create the empty project. Yes. And then choose the model number of HMI. So right now the HMI is Smart 1000. Yes, it has a lot of model that we can choose to match with our project. Because we must choose the correct model number to match with the hardware of HMI, yeah, or touchscreen. So right now my HMI is Smart 700 IE V3. Yes. So let's click here. Yes. And first we need to set the computer IP address to match with the HMI. So right now my HMI is IP address HMI IP address 192.168.2.2. Yes. So we need to change the computer IP address to match with the HMI address. Okay. So let's go to check and set the new IP address. So let's go to IP4 and then check. Here is the rank. Yes, the same as the HMI. Yes. Sorry, .2.3. And we must set the PC IP address 192.168.2. something but not .3. Okay. Example .2.4. Yes. So we can ping to check to confirm. Yeah. So ping 192.168.2.3. Yes. It show like this. It means that we can communication between our PC to the HMI by LAN cable, because right now I already connected the LAN cable from my PC to the PLC, sorry, to the HMI. Okay. So it's very important. Otherwise, we cannot download the project to the HMI if we set the wrong IP address rank. Okay. So the next step, we need to create the connection, right? Click here for connection. Double click here. Example HMI1 and connect to the S7-200. Yes. The command example connect to PLC S7-200 CPU 226. Okay. And here is the connection that we will choose. For right now, we can choose Ethernet or COM port. Yes. and we must show here is the PPI or DP, yes, that we use. So right now I will use PPI, yes, and baud rate around 9600, yes, and here is the address of PLC 2, yes. So that's all for communication setting between HMI and PLC. Okay, so we must follow like this, otherwise we cannot control through the HMI. Yes. So in the next step we need to create the text, right? So click here for create the text. So let's go to the text number 1. Text number 1 is show the value, actual value of temperature, right? So MD4, it is the real, yes. So we can type PT100 actual, and it is the real, right? So choose the real for data type and start from MD2, yes, sorry, MD4. Okay, and the second one is the set point of the analog output, right, to control the actuator. So MD12, yes. So let's go to text here, control valve, set. Okay, it is the real also, MD12. And one more for feedback, right? Feedback from the actuator or control valve. So MD12, sorry, MD20. Okay, MD20. So control valve, feedback. Okay, MD20. Okay, so that's all for our text that need to show or control from the HMI to the PLC. So let's go to screen and then create the text or control to the PLC. Yes, I can use the show temperature. Okay, actual temperature here, so I need to use the IO. Yes, and then go to property and then go to the text. Yes, so first PT100 actual, yes, and it is the real, so it show around 999.99, yes, and go to property to change the color, the field color, and this is the text color. Yes, and we need to change to be center and middle, yeah, and change the text size to this one. Actually we can use the one for decimal, yes. So here is the actual temperature. Yes. So I will click here. Yes. It error a little bit, but we can use it. So we can use it. So I will rename this one to the actual temperature. And this one should be the title. Yes. So test temperature PT100 with and control one with PLC S7-200. Okay. And we need to change the color a little bit to be good. Go to color. For example, this color or yellow color. Yes. For text display, we can choose another color that we want. For example, this color. Yes. And for the font size, we can adjust for text. Example 22. Yes. Maybe 20 is okay. Okay. This one I will change to the white color. Yes, like this. So actual temperature and the unit should be this one and this one. This one should be small a little bit. Yes. And the next step, we need to create the set point for control valve, right? So we can type set point for set point, or we can type SP control valve. Okay. So we can copy. Basically, we can copy, drag and drop by pressing the Control and Shift on keyboard. So the unit is percent, right? 0 to 100%. So we can type percent. And it is the set point action. So go here and then go to the here. It is the output, right? Sorry, it is the input. And this is the output. Okay. And for the text, we need to choose the control valve set point. Yes, here. Okay. And for the last one, we need to create the process variable from the control valve. So feedback FB, yes, FB from control valve, and we can press shift and control, drag and drop to copy, yes. And the unit is version also, yes. And it is the output, yes. And for the text, we need to use the feedback, yeah, this one. Okay, that's all. So we can align to be good looking like this. Okay, and we can download, yeah, by press here, because we need to download to the HMI, right? So press here, and we need to write the IP address of the HMI, yes, here. So 192.168.2.3, right? It is the IP address of HMI, yeah, here. And we no need to tick here, yes. So uncheck. And then press here to download the project to the HMI. But before download, we need to turn off the power, yes. So I will turn off the power and then turn on again. Yes, turn on again. And don't forget, please transfer. Yes. Here, please here. Transfer. And then we can transfer again from our PC to the HMI. So press here and press here. Let's see, the project is transferred from PC to the HMI, but the title is so long, so it's not show. I will correct it. So wait a moment. Maybe I will adjust the size to be 19. Yes, and adjust the align again, and then download again. Yes, but before download, we need to turn off power and turn on again. So turn off power, the HMI, and then turn on again. Yes, turn on again. And don't forget, freeze the transfer again. Yes, transfer. And let's go to the PC and then freeze download again. This here. And project is transferring finished. Yes. So right now it show the title. Yes. So right now the actual temperature around 24, right? So let me show on the HMI. Yes. Okay, HMI show around 24 degrees Celsius, and for control valve set point 0, and the feedback is 25. So because I adjust the milliamp to if I adjust to 0, it will show 0 something. Yes, here. So if I adjust the set point, the temperature, yeah, right now it's 0 milliamp. So if I set example 25%, yeah, let's see the milliamp of analog output is so also 5 milliamp, and the feedback here we adjust the feedback. Yes, example 50%. Yes, feedback also 50. Yes, 100%. Yes, and the HMI will show 100% also. Okay, 20 milliamp. So this is an instruction how to connect the PLC S7-200 with HMI and connect to PLC S7-200 CPU 226. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video also. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to create PID control between temperature controller PT100 to control the valve by using the PLC S7-200 and software Step7 MicroWin V4.0 SP9 and WinCC Flexible Smart version 3. Okay, so in this section I will create step by step about how to create the PID control between temperature and control valve. Okay, for how to wiring and how to create the scaling, I already show and share in the previous video. So today I will explain about the concept of PID control. Okay, so example, we would like to control the temperature on the room or on the tank. Anything else, we can use this concept. Okay, so today I would like to explain about how to control the temperature inside the tank. It means that inside the water tank, because some process we need to control the water temperature, hot temperature or cold temperature. Okay, so we need to recycle the cold water to cold temperature. Okay, so we can use the concept, and this is an example PID tuning that I already created for simulation, and in this section I will create step by step again. Okay, so let's go. So first I will use the existing project that we already learned in the previous video. Okay, so open the project. Yes, so this is a existing project that we already learned in the previous video. So today I will create one more for PID. Yes, so to create the PID control, first go to tool, go to instruction wizard, and go to select the PID and click next. This is the PID, 8 PID that we can use in this project. So first I will use number 0 of PID loop, and then click next. And here is the scaling of PID loop. Example 0 to 100 degrees Celsius, 0 to 10 tons, 0 to 1000 degrees Celsius. So we can set here. Okay, and here is the gain, here is the sample time, integrate time, or derivative time. Here is the parameter that we need to use during we tune the PID. Okay, so in this section I will choose 0 to 100 degrees Celsius for temperature controller, and then click next. So here is the scaling of analog. Yes, so the PV or process variable we can control from 0 to 32,000. Yes, and for analog scaling we can also start from 0 to 32,000. Okay, and then click next. And here is the setting: low alarm, high alarm, or enable analog input module error. So for default we no need to check, and then click next. And here is the address of the PID block. It will start from VB6 to VB125. Yes, so click next. And if we would like to use the manual control output, we can click here. Yeah, check here, click next, and then click finish, and click yes to complete the wizard configuration. Okay, so right now we already configuration the PID block. So here we have the parameter. Yes, So to use this block, we go to the main and we can command everything here. Example, create PID control the temperature of water. Okay, and don't forget use the always on. Yes, so SM 0.0. Yes, and then go to the call subordinate. Yes, and then press here, drag and drop the PID to the network. So we will got this block like this. So here is the PID block. So first is PV. So PV it start from 0 to 32,000. Yes. So we can use the input of temperature. So AIW 0. Okay. And the next step we will use the set point, right? We need to set point. Example, set point 20 degrees Celsius, 30 degrees Celsius, 80 degrees Celsius. So we can use this set point. Okay. So we can use the another memory that we want. So example, this is the real. So VD 700 example, but we need to convert from double integer to real first. Otherwise we cannot set point from the HMI. Yes, so I need to copy. Yes, cut here and then paste here first, and I need to convert from double integer to real. Yes, so example VD 700. So this is VD 710. Yes, and for the manual we can also use it. So I can cut from here. Okay, this one for manual set point. So example, it start from VD 800 and VD 810. Yes, this one. And for manual and auto control, we can use another memory. Example M10.4. Yes, and here is the output. For output, actually we can use the analog output from here. Yes, so I will delete this one because we not use it. The previous video we just simulation. Actually we can use AQW 0. Yes, directly like this, but I need to show on the HMI, right, for percentage to set point the control valve. So I need to use like this. Example VW 90. Yes, and then I will use this one. So move it. Yes, move it. and then I will use move VW90 to AQW0. Yes, so this one to HMI and this one to the control valve. Okay, so the actual temperature will show here, and then the analog output to control the control valve will go here. Okay, so let's compile the project. Yes, okay, error 0, so we can save the project and then download to the PLC. Okay, stop the CPU and then download to the PLC. Okay, start the CPU and then online. Okay, so right now the set point is 0 and the actual temperature around 22 degrees Celsius. So we need to create the HMI for set point or for select from the HMI to control the PID, right? So let's go to software Simatic WinCC Flexible 2008 Smart V3. Yes, let's go. Okay, here is the WinCC Flexible Smart version 3. So let's open. And I will use the existing project that we already learned in the previous video. So open the existing project here, PT100. And let's go to the text to create the new text, right, for set point and for the push button for PID, right? So here is the existing project that we already learned in the previous video. Yes, so maybe I will delete something first. Set point temperature, right? Maybe I will resize the picture to be good looking. Yes, because in the previous video it's so small. Yes, so I can write feedback from control valve. Okay, feedback from control valve, it is the percent, right? 0 to 100%. Okay, and I will increase the font size a little bit to be 22. Yes, or 26. Yes, like this, easy to looking. For unit, maybe I will use this dimension to be the same. Yes, so we need to use 4. Okay, just arrange to be like this first. Okay. So the first one is set point the actual temperature, right? Set point the temperature that we want to control. And the second is the feedback temperature, right? So this one I need to delete first and then copy from here and then edit. So this one is the actual temperature inside water tank. Temperature of water. Okay, just like this. Temperature of water. Okay, align to be like this. So this one is set point that we want to control, and this is the feedback from the temperature controller, and this is a automatic control set point to the control valve, right? So control valve, right? Set point to set point to control valve. It is percent, right? Because it is 0 to 100% also. So this is a feedback from control valve. It is percent also, 0 to 100%. Yes. Okay, like this. And for unit, this is the degree Celsius. And I will copy and paste. It is the degree Celsius also. Yes. So we need to create the new text, right, for set point. So first we need to create VD 700, yes, for set point. So let's go to text, and we can write PID, or we can write temperature CTL, yes, temperature control, and it is the double word, right? So double word, and start from VD 700. And one more for manual control, right? Temperature manual CTL. It is the double integer, right? Let me check again to confirm. So double integer, sorry. It is double integer. Yes. This one double integer also. Yes. And one more, we need to create the actual set point of control valve, right? So VW90. So go to the text and then go to the auto set point valve. It is the word, right? So VW90. Okay, and go to the screen. So the text that we already created here, we use it. For this one, we don't use anymore, so we can delete. Okay, so we use only 5 text. The first one, control valve feedback. Control valve feedback, yes. PT100 actual. Temperature controller set point. Temperature control, yes. Or we can use like this, easy to understand. So example, PID set point. Yes. This one PID feedback. Yes. And this one control valve feedback, right? So control valve feedback, that's okay. And this one temperature control, right? Manual control. And this one for actual. Actual set point, right? Actual set point valve. And one more for manual and auto selection, right? So auto control. Yes. It starts from M10.4, right? So M10.4. It is Boolean. So M10.4. Yes. So we need to create one more button. Yes. For select the PID. So example, manual, sorry, auto control. Yes, auto control. So when we select this button, we can use the auto control. When we not select, we use the manual control, right? So manual, off is manual control, on is auto control. So we can switch this one. Auto control. and for off it is manual control. Okay, like this. So when we not select, it will manual control, and when we select, it will show auto control. Okay, I will adjust the font size a little bit to be 18. Okay, like this. Okay, so we need to insert the text to here, right? So let's go to the text. Is for set point, right? So go to the set point. So PID set point. And this is the actual temperature, right? So actual temperature PID feedback, right? This one. And this is a set point. We need to set point action, right? Output. Let simulation after we can set. So this one set point to control one, right? So we can choose the text. Set point to control one. This one, and we need to scale, right? So let's go to this one. And go to edit. Then go to the linear. And we need to use the set point. Yes, here. Yes. So we can go to the edit linear. Okay, so we can edit. Yes. Go to the set point to control valve. Yes. Go to this point and then click here. So let's go to linear because it is the PLC. So we can use 0 to 32,000. Yes. And 0 to 100%. And click here. And this is a feedback from the control valve, right? So feedback from the control valve. Okay, this one. So we can simulation before download to the HMI. Yes. So this one no need to set point, right? Okay. So we need to set point only this one and this one. and then we need to configure the button. Yes, so go to property and then go to event. Yes, please set bit. So bit point, yes, auto control, and release. We can reset bit auto control also. Yes. So when we press manual mode, we can control from the HMI also. Yes. So we can create one more text for VD800. Yes. It is double integer. So we can go to the text and manual set point. Double integer also, right? And start from VD800. And we can arrange this one. So we can copy this one to here. Okay. So this one manual control. From HMI. And this is the manual control. Yes, this one, right? 800 manual set point, and we need to choose the set point action also. Okay, this one I would like to change a little bit for manual mode, and this one auto mode. Yes, and we can save the project and then download to the HMI. Okay, so before download to the HMI, I will reboot the screen and turn on again, and don't forget freeze the transfer. Okay, right now I already freeze the transfer. Yes, and then we can go to download. Yeah, click this button and then download to the HMI. Okay, the data is transferring. Yes, go to the HMI, and for this tag I will check the actual temperature, right? And this is a feedback is actual set point, right? Control Y feedback, this one I will download again. Yes, because the tag is duplicate. So I will press transfer again, and then download to the HMI again. Okay, so that's all, and then we can control from the HMI. Okay, so right now the analog output show around 0, right? Let me show the output. So the temperature show around 23, 22 something, yes. And the analog output show 0 milliamp, yes. And if I set point to example 60 degrees Celsius, yes. And then I press the auto mode, yes. And then we need to tune the PID, right? So to tune the PID, M10.4 is turned off, right? Turn on or not? Okay, turn on. So let me change a little bit for the button, right? Okay, change this button to okay, I will delete this one. Okay, and then go to the click. So when the click invert bit, yes, we can use invert bit. So invert bit auto control, yes. And then let me download to HMI again. Okay, please button download. Okay, that's all. And then we will test again. So first I need to press the button auto control and then set point value example 60 degrees Celsius. Yes. Let's see the milliamp is start increase. Yes. Because the process variable around uh, 22 degrees Celsius. Yes. So we need to tune the PID. To tune the PID, let's go to Tool and then choose the PID Tune control panel. And then we can go to Help. Yes. And we can follow the manual of PID tuning here. Yes, PID tuning. Okay, here around 0.45 for again, yes, and 0.03 for integrate time. So here we can use another value that we want. Example, I would like to use the gain for 1.5. Yes, it will work fast. Yes, if we set 1.5, let's see the value is up very fast. And I need to check the point on the HMI a little bit because it seems not show the value for here. So here actual, right? Actual set point. It's correct or not? VW90, right? It is correct. It is the output, right? Let's download to the HMI again. Click here and then download. Okay, finish downloading. And we will test again. So here we can tune the PID fast or slow that we want by adjusting the gain or adjust the integrate time. Yes. So right now I will set point again. Example 80 degrees Celsius. Let's see the milliamp is so fast, up so fast. And if we would like to adjust something to faster than here, we can adjust here. Example 3 for gain. So when I have that, it will fast, adjust fast. Yeah, 20 milliamp. It means that 100% to actuator. Yes. So here is 32,000. Yeah, for analog output. But sometimes if we use the gain is too much, the process is so swing. So we need to adjust to be smooth. Yes, follow the manual operation like this. So I will adjust the temperature here to be so around 22 right now. Around 22, yes. So I will adjust the PC100 to be hotter than this one. it start decrease. Yes, around 25 something. 27, 28, 29, 13, 31, 32. I will increase the temperature. 41, 42. Yes, increase. 48. Yes. Let's see, the output is swing, right? Because right now it control. Let's see, the analog output is swing also. Right now the temperatures show around 60 degrees Celsius and set point 80. Yes, and milliamp show around 7 milliamp. Yes. So this is just example about how to create the PID control for control the temperature inside the water tank, or if we would like to control some concept to similar here, we can use this one. Okay, so thank you very much for watching my video, and if everyone would like to use this concept, we can follow my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video, and I would like to request all of you to like, share and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.